Welcome, curious minds and sleepy thinkers. You found a soft place to land where the questions are big and the pace is slow enough not to jolt you out of your pillow cocoon. Tonight, we're going to gently explore some of the most wondrous places in our cosmic neighborhood, starting with a tiny, radiant world bathed in brilliant light. But don't worry, we'll take it slow. This isn't a race through equations. It's more like floating through a galaxy of ideas with a cup of chamomile tea. We'll simply drift wonder and listen to the soft whispers of the universe, allowing ourselves to be carried by the gentle currents of discovery. The quiet hum of the universe often holds secrets close, especially those wrapped in the most blinding light. And so it is with Mercury, the very first of our solar system's planets, a name whispered through thousands of years, carrying the essence of a swift Roman god. We've known it was there, a sparkling point in the cosmic tapestry, never truly hidden in the vastness of night, but rather embraced by the sun's most brilliant, unwavering gaze. It is a paradox, isn't it? A world so close to our star, always visible, always there yet in the grand narrative of our space. Faring history, it remains the least explored of the rocky planets. Only 2 delicate probes have ever dared to journey to its fiery embrace, leaving so much of its story untold. So many of its facets still veiled in mystery. Why this quiet reluctance, this cosmic pause in its exploration? Was it simply deemed uninteresting, a small, unremarkable pebble in the celestial pond? Or does its proximity to the sun, that fiery heart of our system, present challenges so profound that they have held us back for generations? Tonight, we will gently step into this quiet enigma, this sun-kissed world, and begin to uncover what we truly know. What whispers of its characteristics and history have reached us across the vast distances, and how through sheer ingenuity and a touch of cosmic serendipity, we have managed to learn about it at all. Let us begin by simply imagining its physical form. When we conjure an image of Mercury in our minds, the first thought that often arises is that it is simply the closest planet to the sun. Perhaps we picture it as a giant barren rock silently drifting in the cosmic ocean. And while that initial sketch holds a grain of truth, it is but a fleeting impression, for Mercury is so much more intriguing than our first thoughts might suggest. In its very essence, it holds surprises, a quiet complexity that beckons us to look closer, to listen to the subtle stories etched upon its ancient surface. For instance, when my mind drifts to Mercury, I often find a curious echo of our own moon. They share a certain silent, cratered visage, a look of ancient wisdom. Yet, if we gaze upon Mercury in its true colors, a profound difference emerges. Our moon, in its stark beauty, often appears in shades of gray, a monochrome ballet of light and shadow. But Mercury, when illuminated without the filters of our earthly perspective, reveals a surprisingly rich palette. It is not merely gray. Instead, it offers a subtle symphony of creams, beiges, and speckled grays, touched with a hint of warm earth tones. It's as if an artist has painted it with a gentle earthy wash, allowing the subtle nuances of its composition to shine through. This initial glimpse, this quiet revelation of color, is but the first whisper of its deeper nature. And what else might this unassuming world hold within its ancient core? Here is a quiet marvel. Did you know that Mercury is composed of approximately 70% metallic materials and about 30% silicate materials? This means it is in fact more metal than rock. Imagine, if you will, a hidden core of forgotten treasures, a heart of pure gleaming essence, rather than a mere stony mass. It is a world where the very foundations are forged, not just from the dust of creation, but from the shining elements that once swirled in the earliest cosmic furnaces. This unusual composition bestows upon Mercury an extraordinary quality. Its density is the second highest in our entire solar system. At 527 grams per cubic centimeter, it is only slightly less dense than Earth, our own blue planet, which holds the record at 5.5 and 15 grams per cubic centimeter. Imagine the sheer weight of such a world, even in its compact form. If Mercury, by some grand cosmic rearrangement, happened to be the same size as Earth, its immense density would mean it would possess a gravitational pull almost identical to our homeworld. You could stand on its surface and feel the familiar embrace of gravity, a comforting tug that roots us to our planet. But being the compact world that it is, a gentle whisper of a planet, its surface gravity is a lighter touch, a mere 3.7 meters per second squared. To understand this a little better, if we were to compare its gravitational embrace to Earth's, it would be a softer, less insistent pull. It's a subtle dance where steps feel lighter and leaps might carry you a little further into the thin air. This means that Mercury's surface gravity is only marginally less than that of Mars, our red neighbor. And when we consider that Mars is a significantly larger planet, this subtle comparison speaks volumes about Mercury's remarkable density, its ancient heart holding so much compacted essence within its smaller frame. Before we leave this gentle contemplation of Mercury's size, let me offer one last and perhaps surprising comparison. Let us envision two of the solar system's most magnificent moons, Ganymede, Jupiter's colossal companion and the largest moon in our system, and Titan, Saturn's biggest moon and the second largest overall. Now picture these giants alongside Mercury. From our perspective, these two majestic moons appear larger than Mercury. Indeed, they stretch across more cosmic real estate. However, in a beautiful testament to Mercury's unique density, their total masses are far, far less. It is a quiet reminder that appearances can sometimes be deceiving, that true weight and substance are often hidden beneath the surface, whispering their secrets only to those who look beyond the obvious. Mercury, in its compact form, holds more fundamental essence than these grander celestial companions. So, this little world so close to the Sun is not just a barren rock. It's a sphere of surprising colors, a heart of metal, and a subtle gravitational pull. It is a world of quiet contrasts where the intense heat of its sun-drenched side meets the profound cold of its shadowed pole, a place where time itself seems to play tricks on our understanding. As we allow these initial impressions to settle, let us prepare to delve deeper into its ancient surface to trace the stories etched by cosmic impacts and geological whispers, and to listen to the faint echoes of its remarkable past. This journey into Mercury is not a loud pronouncement, but a soft unfolding, a gentle exploration of a world that holds more mystery and quiet wonder than we first imagined. The more we learn, the more we realize how much still lies veiled in that brilliant light. The tapestry of our solar system is vast, woven with threads of fire and ice gas and rock. Each world in its unique way contributes to the grand narrative, holding lessons and wonders for us to discover. Mercury, often overlooked in its radiant proximity to the Sun, quietly offers its own profound insights. It reminds us that grandeur is not always measured in size or outward display, but sometimes in the very essence of being, in the silent, enduring strength that comes from being forged so close to the heart of a star. Its quiet resilience, its ancient wisdom speaks to us across the vastness, inviting us to look closer, to listen more intently to the subtle harmonies of the cosmos. As our minds gently drift through these initial observations, we begin to appreciate the layers of complexity that lie beneath Mercury's seemingly simple exterior. The very composition of its being so rich in metallic elements suggests a profound difference from the rocky worlds we might instinctively compare it to. It is as if Mercury carries within it a denser, older memory, a testament to the conditions in the earliest swirling mists of our solar system's formation. Imagine the raw materials, the heavy elements drawn together by gravity's invisible hand, compacting into a world that, despite its modest size, holds an extraordinary internal weight. This internal density is not merely a scientific fact. It is a whisper of its history, of the forces that shaped it into the unique body it is today. And in considering its gravitational pull, so similar yet so distinctly lighter than Earth's, we begin to feel the gentle tug of its presence. It is a force that would allow for different possibilities on its surface, a subtle alteration of every fall, every leap. One might imagine, with a gentle contemplation, how different a step would feel, how the dust might settle with a different grace under such a lighter hand. This subtle difference is a quiet invitation to imagine. The comparison with Ganymede and Titan, those majestic moons, further deepens our appreciation for Mercury. They are grand in their expanse, holding their own regal places in the outer reaches of the solar system, reflecting the light of distant suns and orbiting gas giants. Yet Mercury, smaller in outward appearance, surpasses them in the very essence of its being, in its compacted mass. It is a beautiful lesson in the universe's quiet artistry, where size is but one dimension of beauty and significance. True wonder often resides in the unexpected, in the intricate details that reveal themselves only when we slow down and truly look. This initial journey into Mercury's physical form is but the opening of a story, a soft prelude to the grander narratives of its surface, its tenuous breath of an atmosphere, and the intricate dance of its orbit. We prepare to explore the ancient scars upon its face, the tales of cosmic collisions that shaped its very being. We will gently uncover the extreme conditions that define its days and nights, the subtle, almost imperceptible whisper of an atmosphere, and the invisible shield that protects it from the sun's fierce embrace. Each new layer of understanding, each new metaphor we uncover, will bring us a little closer to this fascinating world, allowing us to feel its quiet presence in the vast, silent theater of space. So let your thoughts gently linger on this image of Mercury, a planet of subtle colors, a heart of ancient metal, a quiet dancer in the brilliant light of our sun. It is a world that continues to surprise, a testament to the endless wonders that await our gentle exploration in the cosmos. In the quiet of the night, we can almost hear the soft hum of its rotation, the gentle whisper of the solar wind against its exosphere, a lullaby from the edge of the inferno. As we continue our quiet journey through the vastness, our gaze now settles upon the surface of Mercury itself, a landscape that holds the deep imprints of time etched by cosmic forces that have shaped our solar system since its very infancy. When we look closely, we find that its appearance is remarkably similar to that of our own moon. Imagine, if you will, a well-worn parchment stretched across the silent canvas of space, intricately etched with countless cosmic tales. This ancient surface displays extensive mare-like plains, vast stretches of smoother, darker terrain, alongside a dense tapestry of heavy cratering. These countless pockmarks are not mere imperfections. They are testament to a profound geological inactivity, a silent testament that for billions of years, this world has largely remained a frozen moment in time. Its inner fires long settled its outer skin, preserving the echoes of the earliest, most violent days of our cosmic neighborhood. Yet even in its stillness, Mercury whispers stories of a time when it was far from quiet, when internal forces stirred beneath its nascent crust. One of the most distinctive features you'll find etched upon its surface is the presence of many narrow ridges, sometimes stretching for hundreds of kilometers in length. These are known as scarps, and they are like the subtle wrinkles on an old face, each one a quiet line telling of its long and profound life. They speak to us of a past where Mercury was indeed geologically active, a time when its very skin was still forming and shifting. These scarps are believed to be the result of the planet's slow, gentle contraction as its interior cooled and solidified over eons. Imagine the planet like a cooling apple slowly wrinkling its skin as its core shrinks. This grand, slow process of shrinking creates immense stresses on the rigid outer crust, causing it to buckle, fold, and thrust upwards, forming these delicate, silent ridges across its ancient face. We will, in our quiet contemplation, return to these fascinating features later, for they hold further clues to Mercury's deep, fiery past. But amongst the myriad of craters that pepper Mercury's face, one truly stands out, a colossal mark of cosmic might. It is the Caloris Basin, a truly immense impact crater with a diameter of a staggering 1,550 kilometers. To truly grasp its scale, imagine a cosmic titanic kiss, a collision so powerful that it resonated through the entire world. This impact was not just a mere dent, it was a cataclysmic event that unleashed forces beyond our easy comprehension. The sheer energy released caused widespread lava eruptions, vast seas of molten rock welling up from beneath the wounded surface, flowing and cooling to form smooth plains within the basin. And as if to further mark its power, the impact left a remarkable concentric ring, a raised circular feature over 2 kilometers tall, surrounding the very heart of the impact. It is like a giant ancient eye gazing into the past, its structure a permanent monument to a moment of unimaginable cosmic violence. And the echoes of this colossal impact extend even further, reaching across the entire planet. At the exact opposite point of the globe from the Caloris Basin, its antipode, lies a large region of unusually hilly and fractured terrain, a landscape so chaotic and jumbled that it has been aptly named the Weird Terrain. Imagine a landscape of shattered echoes, a consequence of cosmic reverberations. Scientists believe that the seismic waves generated by the immense Caloris impact traveled through Mercury's interior, converging and amplifying at the antipode, literally shaking that distant region to its core, tearing it apart and creating this strangely disfigured landscape. When we compare this chaotic region to the relatively smoother, more ordered expanse of the rest of Mercury, the reason for its peculiar name becomes beautifully clear. It is a subtle yet profound reminder of how a single powerful event can ripple through an entire world, leaving its mark even on the farthest shores. Now let us imagine ourselves standing on the surface of Mercury, a place of profound contrasts. What would it truly be like to experience this world firsthand? To begin with, the surface temperature is a symphony of extremes, hugely different depending on where you stand and whether the sun's light graces your presence. It can range from a chilling 73 degrees Celsius in the deepest, darkest parts of its night to a scorching over 400 degrees Celsius during the relentless embrace of its day. This is a world where fire and ice meet daily, not in a gentle dance, but in a stark, uncompromising division. At the poles, where the sun's rays strike at a very low angle, if at all, the temperature never rises above a frigid 10 degrees Celsius. This profound cold is partly because Mercury has no significant atmosphere to retain the heat, no cozy blanket to hold the day's warmth. This means there's a vast and immediate difference between the equator, where the sun beats down mercilessly, and the poles, which remain in a state of eternal twilight, guarding frosty secrets. But this extreme variation, this dramatic swing between scorching heat and biting cold, is also deeply intertwined with Mercury's unique orbit and rotation, a complex cosmic dance we will unravel in our quiet moments later. At the subsolar point, the exact spot where the sun is directly overhead, temperatures can soar to about 400 degrees Celsius, hot enough to melt lead. While on the dark side of the planet, where the sun's light does not reach, temperatures average a bone-chilling 163 degrees Celsius. The reason for this dramatic difference, this stark divide, lies in Mercury's very essence. It is simply too small and too hot for its gravity to retain any significant atmosphere over long periods of time. Imagine a thin veil, a gossamer shroud that is simply too weak to hold on to the precious warmth received from being so close to the sun. This inability to cling to the heat is precisely why the dark side of the planet plummets into such profound cold, a frigid counterpart to the sun-baked day side. Yet to say Mercury has no atmosphere at all would be a gentle oversight. It does possess something far more subtle, a delicate and ethereal presence known as an exosphere. Imagine an extremely thin, almost whisper-like volume surrounding the planet. It is not a true atmosphere in the way we understand it on Earth, where molecules are densely packed and constantly colliding. No, in an exosphere, The molecules are still gravitationally bound to the planet, held in its gentle embrace, but their density is so incredibly low that they simply do not collide with each other. It cannot behave like a gas, for the particles are too few and too far between. In our minds, let us envision it as a whispered breath, a gossamer shroud, barely there yet vital in its silent dance. Photographs, such as those sent back by the MESSENGER probe, offer us a glimpse into this ethereal realm, showing Mercury's exosphere as a faint, almost invisible halo around the planet. This exosphere is profoundly affected by the ceaseless breath of our sun. When the solar wind, a constant stream of energetic, charged particles flowing outwards from the sun, gently caresses the planet, it rips off certain atoms from this tenuous exosphere. And what remains trailing behind Mercury as it journeys through space is a delicate wisp, a faint trail of these escaping atoms. We call this the planet's tail, and in a quiet way, every planet in our solar system possesses this to some extent. Even Earth, our vibrant blue home, has an exosphere, though ours begins much higher at about 600 kilometers above the surface. It is in essence the very point where the vast silence of space gently meets the protective embrace of our atmosphere. In Mercury's case, however, this exosphere is far from stable. Imagine a dance of cosmic dust where atoms are continuously lost to the solar wind, drifting away into the void, only to be replenished from a variety of subtle sources. We'll explore these intricate processes in more detail later, for they reveal much about the planet's hidden dynamics. This constant shedding and renewal is a testament to the fragile balance that exists so close to our star, a world constantly giving of itself, yet always finding ways to renew its subtle cloak. Amongst the most compelling discoveries about Mercury, one stands out with quiet significance. NASA has been able to confirm that craters at Mercury's North Pole contain water ice. Imagine frozen pearls glistening in the eternal darkness of those deepest shadows, unexpected oases in a world seemingly scorched by the sun. This is a profound testament to the power of shadow and the surprising resilience of ice, even on a planet that embraces the sun so fiercely. These icy pockets remain forever protected from directly interacting with the sun's searing light rays, cradled in the perpetual night of deep crater floors, and as if to add another layer of quiet wonder to this small, dense world. Mercury also possesses something that Mars, our red neighbor, sadly lacks: an actual magnetosphere, a magnetic field that gracefully wraps around the entire planet. It is a subtle shield, an invisible embrace deflecting the sun's fiercest breath. Though it is only about 1.1% as strong as Earth's own magnificent magnetic field, it is still powerful enough to deflect a significant portion of the relentless solar wind, steering it gently around the planet. Imagine a quiet guardian, humble in its strength, yet steadfast in its duty. However, the dance between Mercury's magnetosphere and the sun's power is unique. Due to Mercury's intimate proximity to the sun, the solar wind pressure here is far greater than it is around Earth. Now pair this intense solar pressure with Mercury's comparatively weak magnetic field, and the result is a magnetosphere that is compressed closely to the planet's surface. Unlike Earth's, which extends many times the diameter of our planet away from its surface, Mercury's magnetic bubble is pulled in tight, a close-fitting cloak, against the cosmic storm. Interestingly, these very factors conspire to make Mercury's magnetosphere exceptionally dynamic. What does this entail? Well, for one, reconnection events are astonishingly common, occurring 100 times more frequently around Mercury than around Earth. Imagine threads of energy, invisible lines of magnetic force snapping together and then reconnecting with sudden bursts of power, a silent crackle in the void. These events happen when the charged solar wind, like an insistent cosmic current, pushes against the planet's magnetosphere. When the magnetic field lines stretched taut snap and rejoin, they allow a few of these charged particles to break through, entering a region of plasma that trails behind the planet, forming its magnetotail. Simulations of these plasma regions beautifully illustrate the flows created by these very reconnection events, a cosmic ballet of invisible forces. Another fascinating feature of this magnetosphere that MESSENGER, our brave little probe, detected was the presence of energetic bursts of electrons. These events produced hundreds of thousands of electron volts of energy, invisible whispers of power, radiating through the cosmic expanse. As MESSENGER gracefully orbited Mercury, it picked up thousands of these remarkable events. Mysteriously, they were mainly localized in the northern hemisphere and appeared to be compressed towards the planet along the sun-facing side. This remains an ongoing field of quiet study, a beautiful puzzle that scientists continue to ponder. However, the gentle speculation suggests that these electrons have been accelerated through breakdowns in the magnetotail, then gracefully follow the direction of the magnetic field, flowing from the South Pole to the north, a silent river of energy coursing through Mercury's unseen shield. The more we learn about this compact, sun-kissed world, the more its subtle complexities reveal themselves, inviting us to wonder at the intricate workings of the cosmos, even in the smallest of its children. Its stillness is an illusion, for within and around it, a silent, powerful dance of forces continuously unfolds. The beauty of such discoveries lies not just in the answers they provide, but in the new questions they spark, like tiny stars igniting in the vast darkness of our understanding. Mercury, with its ancient surface and its subtle magnetic heartbeat, continues to whisper these questions to us across the cosmic void. What further secrets does its hidden core hold, the metallic heart beating so close to the sun? How do the dance of its exosphere and the invisible shield of its magnetosphere truly interact in such extreme conditions? Each piece of data, each image sent back by our patient probes, is like a single thread in a grand unfinished tapestry, inviting us to imagine the full glorious design. As our gentle contemplation of Mercury's surface, its thin veil of an exosphere, and its delicate magnetic shield comes to a quiet close, we carry with us an enhanced sense of its profound uniqueness. It is not merely the closest planet to the sun. It is a world forged in the crucible of extreme proximity, a testament to resilience and a silent guardian of ancient secrets. The stark contrasts of its temperatures, the subtle ballet of its escaping atoms, and the mysterious whispers of its magnetic field all paint a picture far richer and more complex than any initial glance could suggest. This is a world where every feature, from the deepest crater to the faintest magnetic ripple, tells a story of cosmic forces at play, inviting us to listen, to learn, and to wonder. Let us allow these images to gently fade and the quiet contemplation of Mercury's ethereal qualities to settle in our minds, preparing us for the next layer of its intricate story, the dance of its orbit, and the peculiar rhythm of its days. The universe, in its boundless wisdom, always has more to reveal, more quiet wonders to unfold, for those who approach with curiosity and a gentle heart. As we gently float onward in our cosmic journey, our attention now turns to the celestial ballet that Mercury performs around our sun, a dance governed by invisible forces and intricate rhythms. This small world holds the distinction of having the most eccentric orbit of all the planets in our solar system. Imagine a cosmic oval, sometimes drawing incredibly close to its fiery dance partner, the sun, at a mere 46 million kilometers, and at other times, gracefully swinging further away to a distance of 70 million kilometers. This significant variation is like a celestial breath, a planet, sometimes drawing deeply into the sun's radiant warmth, and at other times exhaling, drifting to a more distant, cooler embrace. It is a subtle yet profound dance, marking the passage of its unique year. And what a year it is! Mercury takes about 88 Earth days to complete just one orbit around the sun. Imagine the swiftness of this revolution, a quiet, hurried journey around the central fire, compared to our own leisurely 365-day cycle. This rapid orbital pace, however, is beautifully intertwined with another fascinating rhythm of the planet, its rotation around its own axis. Here, the universe reveals a peculiar and elegant synchronicity, a cosmic twist that once baffled astronomers. Mercury exhibits a 3-2 spin-orbit resonance. This means quite remarkably that for every 2 times it completes an orbit around the Sun, it spins exactly 3 times around its own axis. Imagine a rhythmic, intertwined waltz between spin and sway, a perfectly choreographed cosmic dance that is both precise and profound. To truly grasp this, let's consider a sidereal day on Mercury, which is the time it takes for the planet to rotate once on its axis relative to the distant stars. This takes about 59 Earth days. Now here's where the cosmic coincidence comes into play. This 59 Earth day sidereal period is almost exactly half of Mercury's synodic period in respect to Earth, which is 116 days. The synodic period is the time it takes for Mercury to return to the same position relative to the Earth and the Sun, say, from one superior conjunction to the next. So between 2 conjunctions of Earth and Mercury, our little neighbor rotates on its axis precisely twice. Historically, this curious coincidence posed a grand problem for astronomers, leading to a long-held misconception. For the longest time, we believed that Mercury was tidally locked to the Sun, meaning it always showed the same face to our star, much like our moon always shows the same face to Earth. You see, because Mercury orbits so closely around the Sun, it was always tricky for astronomers on Earth to get a good clear look at it for most of its year. It was often lost in the Sun's glare, a shy celestial body. When it finally drifted into a good viewing angle from our perspective, a prime observation alignment that occurred roughly every 118 days, we would gaze upon its face. And then, 118 days later, when it next reached this prime viewing position, we would again see what appeared to be the exact same face. To the astronomers of old, this seemed to be conclusive proof Mercury must be tidally locked its rotation, forever bound to its orbit, always presenting the same silent visage to its fiery lord. What those early astronomers didn't realize, what the subtle cosmic dance kept secret for so long, was that Mercury had in fact rotated exactly twice on its axis during that time. It was a celestial magic trick, a trick of perspective played out across the vast canvas of space. It wasn't until the advent of radar observations of the planet, a new way of listening to its distant whispers, that we finally found out the truth. Mercury does indeed rotate, and slightly faster than it orbits, revealing its true complex rhythm. This beautiful 3-2 orbital resonance creates an astonishing phenomenon for anyone who might stand on Mercury's surface. Imagine for a moment being a silent observer on this distant world. The concept of a day from sunrise to sunrise, what we call a solar day, would be profoundly different from our earthly experience. On Mercury, a single solar day would stretch out to be equivalent to 2 Mercurian years. To truly visualize this, imagine the Sun rising relatively quickly in the sky, a swift ascent from the horizon. But then, as it approaches midday, its apparent motion would begin to slow down, almost as if hesitating. And here's the truly mind-bending part. For a brief period, it would appear to start going backwards in the sky, a curious cosmic backtrack, before resuming its forward journey towards sunset. This entire celestial spectacle from one sunrise to the next would take a whole Mercurian year. And by extension, a single night on Mercury would also stretch out for an entire Mercurian year. It is a day that stretches into an eternity, a sun that plays tricks on the eye, challenging our very perception of time. This strange celestial choreography, where the Sun seems to pause and reverse its course, happens because of a delicate balance between Mercury's orbital speed and its rotational speed. Approximately 4 Earth days before perihelion, the point where Mercury is closest to the Sun in its eccentric orbit, the speed at which Mercury travels along its orbit subtly equals the speed at which it is rotating. At this fleeting moment, the Sun's apparent motion in the sky seems to stay stationary, a moment of cosmic stillness. Then, at perihelion itself, Mercury's orbital speed actually exceeds its rotational speed. So to a person actually standing on Mercury, the sun appears to move backwards, a gentle brief retreat across the heavens. 4 days after perihelion, as the planet continues its journey, the sun's normal motion gracefully resumes. You can visualize this even clearer from a top-down perspective of Mercury, where the subtle interplay of these speeds becomes a mesmerizing ballet. Twice a day on one of its poles, the sun seems to pause a brief silent hesitation and then continues its relentless journey again. It's a remarkable testament to the intricate physics that govern planetary motion, revealing that even seemingly simple movements can harbor profound and beautiful complexities. Something else to gently notice about Mercury's unique orbit is its subtle tilt. Its orbital plane is inclined by 7° to the plane of Earth's orbit. Imagine two delicate, invisible cosmic sheets, one for Earth's path and one for Mercury's gently tilted relative to each other. As a quiet result of this inclination, we can only witness a rare celestial alignment, Mercury transiting or passing directly in front of the Sun when it is perfectly aligned between us on Earth and the Sun itself. And because of this 7° incline, this beautiful phenomenon only happens about once every 7 Earth years. It is a fleeting shadow play, a rare cosmic kiss, a moment when Mercury briefly etches its silhouette against the fiery disk of our star, a silent, humble reminder of its unique place in our solar system. The final piece of this orbital puzzle, the last whisper about Mercury's rotation, concerns its axial tilt. This is the tilt of the planet's rotational axis relative to its orbital plane. For Mercury, this tilt is almost zero, with the best measured value as incredibly low as 0.027 degree. This is even smaller than that of mighty Jupiter, which has been measured at 3.1 degrees. Imagine a perfectly upright spinner, atop almost perfectly balanced with virtually no wobble as it journeys through space. This near-zero axial tilt means that Mercury experiences virtually no seasons, unlike Earth, with its noticeable 23.5° tilt. Every part of Mercury receives roughly the same amount of solar radiation throughout its orbit, leading to those extreme temperature variations that remain constant year-round, a world of stark contrasts without the gentle sway of seasonal change. And finally, to bring us back to our home, let us imagine for a moment what it would be like to see Earth from Mercury. Well, here we are, just a couple of pixels across a tiny distant blue speck in the vast cosmic ocean. This profound image, a testament to our enduring curiosity, was captured by the Messenger probe several years ago. In that tiny, almost imperceptible smudge of light, every single one of us, barring the newborns, was present, a silent, collective presence on that distant pixel. It is a humble reminder of our tiny blue home in the vastness, a delicate world teeming with life seen from the stark, sun-baked surface of its closest neighbor. This journey through Mercury's dance in space and time reveals a world far more intricate than its simple appearance suggests. It is a planet that challenges our conventional understanding of day and night, of seasons and gravitational embrace. Each detail, from its eccentric orbit to its peculiar spin, contributes to a rich tapestry of cosmic phenomena, inviting us to ponder the countless ways in which the universe expresses its boundless creativity. As we drift from this contemplation, we carry with us the image of a planet both ancient and dynamic, a world of silent wonders and whispered secrets, waiting for further gentle exploration. The universe, in its quiet wisdom, always has more to teach us about the delicate balance of existence. The precise ballet of Mercury's motion, once a source of deep scientific confusion, now serves as a beautiful illustration of how our understanding of the cosmos evolves. It reminds us that what appears to be static or simply understood from our limited perspective often holds layers of dynamic complexity. The revelation of its 3-2 spin-orbit resonance, a number so simple yet so profound in its implications, transformed our view of this planet. It taught us to question our assumptions, to develop new ways of seeing. Beyond the visible light, to listen to the subtle echoes of radar, and to piece together a truer picture from fragmented whispers. Imagine the quiet dedication of the astronomers, who for centuries meticulously observed Mercury straining their eyes against the sun's glare, patiently waiting for those fleeting moments of clear observation. Their initial conclusions, though later refined, were born from a deep-seated desire to understand, to map the heavens with the tools available to them. And then the new age of technology with its radar whispers offered a fresh perspective like a gentle breeze, clearing a fog, revealing the true intricate dance. This progression from careful observation to technological innovation is a testament to the persistent, humble curiosity that drives us to unravel the universe's puzzles. The concept of a solar day on Mercury, stretching across 2 of its years, is perhaps one of the most mind-bending aspects of its existence. It challenges our fundamental human experience of time rooted in the familiar rhythm of Earth's 24-hour cycle. To imagine the sun pausing, then retreating, then continuing its journey, paints a vivid picture of a world where time itself feels fluid, a subjective experience shaped by the planet's unique cosmic tempo. It's a reminder that our understanding of reality is often shaped by our vantage point, and that the universe holds infinite variations on the themes of existence. And in the whisper of Mercury's near-zero axial tilt, we find another quiet contrast to our own world. No gentle changing of the seasons there, no shifting dance of spring, summer, autumn, and winter. Instead, a relentless consistency, an unwavering embrace of either blistering heat or profound cold, depending on whether the sun's gaze falls upon it. It is a world of permanent extremes, a testament to its steadfast, unyielding nature, a quiet defiance of the seasonal rhythms we hold so dear. Finally, that distant photograph of our Earth, a mere couple of pixels from the silent vantage point of Messenger, offers a profound moment of reflection. It shrinks our world, our grand human narratives, our bustling lives into a single, almost imperceptible point of light. Yet in that very smallness, there is a quiet beauty, a humbling reminder of our shared journey on this tiny blue marble, seen from the harsh, illuminated expanse of Mercury. It ties us in a single thread of light to this ancient, sun-kissed world, reminding us that we are all part of the same grand unfolding cosmic story, and that every distant speck holds its own universe of wonders. Our quiet journey now takes us to the vast, silent stretches of space, where the very act of reaching out, of extending our curious gaze beyond our home planet, becomes a story of immense dedication and ingenuity. Let us gently unravel the history of humanity's quiet quest to visit Mercury, a tale that holds unexpected turns and profound challenges. When mankind first began to send its delicate spacecraft out to explore the sprawling canvas of our solar system, the order in which we greeted our planetary neighbors might seem a little odd at first glance. The first planet to receive a visitor was Venus, our closest veiled neighbor, in 1962. Next came Mars in 1965, the red whisper in the night sky. Then the majestic giant Jupiter in 1973. Only after these journeys did we finally reach out to Mercury with the Mariner 10 probe arriving in 1974. This sequence of visits is a curious cosmic itinerary, saving what might seem like the easiest journey for later. Consider the numbers. The closest distance between Earth and Mercury is a mere 77 million kilometers. In fact, on average, it is the closest planet to us in the solar system. Now compare that to Jupiter, which at its closest is a staggering 588 million kilometers away, almost 8 times the distance to Mercury. Yet Jupiter received multiple return visits. It was graced again in 1974, twice in 1979, and then repeatedly in 1992, 1995, 2000, and 2007. Numerous missions were also launched to Saturn, Uranus, Neptune, and even to the fleeting comets and wandering asteroids. Meanwhile, Mercury, after that initial brief encounter, received nothing for 3 long decades. It was a long silence, a forgotten chapter in the book of planetary exploration. Was this quiet abandonment because Mercury was deemed uninteresting, its secrets already fully unveiled by that single pioneering mission? Not at all. The very first mission, Mariner 10, was merely a flyby, a fleeting glance as it swept past the planet. It only managed to map about 40 to 45% of Mercury's ancient surface, leaving more than half its story untold, its features still veiled in shadow. No, the real reason for this prolonged silence, this cosmic pause, lies in the profound challenges that Mercury itself presents. It is quite simply one of the most demanding planets to visit in our entire solar system. Why such difficulty? Imagine approaching a forge, a place of intense, unyielding heat, where instruments might melt, and even the grandest dreams could fade. Due to its intimate proximity to the Sun, Mercury exists in a perpetual furnace. Its surface temperature soars to highs of 430 degrees Celsius, a heat so intense it could bake any ordinary probe to dust. So any delicate spacecraft daring to venture there would need to be remarkably heat-resistant, clad in layers of ceramic armor designed to withstand the Sun's relentless fiery embrace. But the heat is only one part of the challenge. That very proximity to our star, that immense radiant presence, creates another even more formidable obstacle. Any probe launched towards Mercury experiences an incredible acceleration due to the Sun's immense gravitational pull. Imagine trying to swim against a cosmic current, a powerful, relentless river that pulls everything deeper into its fiery heart. This is the challenge. Combating the Sun's gravity, slowing the spacecraft down enough to be gently caught up in Mercury's orbit, required an extraordinary amount of rocket fuel. It would be like trying to navigate whitewater rapids upstream, using only the strength of your arms. For the class of spacecraft typically used for such planetary missions, known as Discovery-class carrying, that much fuel seemed impossible. The sheer weight of it would be prohibitive, and here lies the crux of the dilemma: weight. Weight is a profoundly challenging limitation when it comes to spacecraft. The heavier a craft, the larger and more powerful a rocket is needed to lift it out of Earth's gravitational embrace to send it on its cosmic journey. And naturally, the larger the rocket, the more astronomically expensive everything becomes. Scientists, in their quiet ingenuity, strive to keep everything as light as possible, a delicate balance of engineering and economy to reduce this colossal cost. Fuel, while essential, takes up precious weight allocations that could otherwise be dedicated to sophisticated scientific instruments, the very eyes and ears of our distant probes. So scientists often try to take only what is absolutely necessary, a minimalist approach to cosmic travel, hoping it will be enough to help them complete their arduous journey. For approximately 30 years after Mariner 10's fleeting visit, scientists were confronted with this formidable wall. They could conceive of no practical way to load enough fuel onto a probe to enable it to slow down sufficiently to enter Mercury's orbit, especially if they also wished to include the vital scientific equipment needed to truly understand the planet. So after the limited success of Mariner 10's flyby missions in 1974 and 1975, the quiet exploration of Mercury was placed on a long, patient hold. It was a period of silent contemplation, a waiting game for a breakthrough that seemed almost impossible. But then, in 1985, a brilliant mind, an expert in orbital mechanics named Chen Wang-Yen, quietly realized that there was indeed a way. She envisioned a method of getting a probe into orbit around Mercury that didn't require any revolutionary new technology, no fantastical engines yet to be invented. Instead, her insight lay in understanding the delicate ballet of gravity itself. She had worked out a particular incredibly intricate route an orbiter could take around the solar system, a series of gentle cosmic slingshots that would gradually slow it down enough to enter Mercury's orbit with only a few subtle course corrections, rather than making a direct head-on dash towards Mercury, which would require an impossible amount of braking fuel. The orbiter would need to embark on a much longer, more circuitous path. How long, you might wonder? Under Chen Wang-Yen's elegant model, a craft would orbit the Sun approximately 15 times a patient and winding journey. Along this grand loop, it would perform a series of delicate dance moves, flying past Earth once, then Venus twice, and then Mercury itself 3 times. These aren't just flybys for observation. They are crucial gravity assists. By skimming the atmospheres of these planets, vital speed could be gently shaved off through atmospheric drag, and more powerfully, through the subtle pull of their gravity. Each planetary encounter would act like a cosmic brake, slowly bleeding off the probe's immense speed, allowing it to gradually fall deeper into the sun's gravitational well, but with just enough control to avoid being consumed. After these 3 crucial Mercury flybys, the probe would finally be slow enough, gentle enough, to enter into its permanent embrace on the 4th pass. The entire route, a testament to cosmic patience, would cover a mammoth 7.9 billion kilometers and take a staggering 6.5 years to complete. It was a patient pilgrimage, a long, slow drift, designed to reach its ultimate destination with grace and precision. Chen Wangyan's quiet, brilliant findings were not immediately picked up. Sometimes even the most elegant solutions need time to resonate, to be truly understood and embraced by the wider scientific community. But as the years gently turned in 1998, NASA began to take a serious interest in her groundbreaking idea. After thoroughly assessing the feasibility of her meticulously planned route and seeing the quiet promise it held, they gave the green light. The Messenger probe, a testament to this persistent human curiosity and ingenuity, was finally launched in 2004, embarking on its long, patient journey to the sun-kissed world. Messenger, whose full name whispers its purpose. The Mercury Surface Space Environment, Geochemistry and Ranging Probe, was a remarkably compact and resilient Voyager. It was only about 1.8 meters long and 1.3 meters wide, weighing a relatively modest 100 kilograms. This was considered small and light for a typical NASA mission, especially when compared to giants like the Juno probe, which stretches over 20 meters in length with its immense solar arrays. Messenger was designed with a delicate balance in mind. Every gram accounted for every instrument chosen with purpose. This quiet, determined craft came equipped with a powerful thruster, its silent engine ready to make precise course corrections in the vast emptiness of space. Crucially, it was clad in a ceramic heat shield, a powerful armor designed to protect its delicate internal systems from the sun's unimaginable heat, 7 times brighter and more intense near Mercury than it is on Earth. 2 solar panels like delicate wings would not only gather the sun's energy, but also play a clever role in deceleration, as we shall see. And within its protected core lay a whole suite of sophisticated scientific equipment, a collection of highly sensitive instruments for imaging Mercury's surface and measuring data from its mysterious environment. Scientists filled with a quiet hope and profound anticipation designed Messenger to seize this unprecedented opportunity to learn as much as they possibly could about Mercury. Their goals were vast and ambitious, yet approached with a humble curiosity to understand the chemical composition of Mercury's surface, to unravel its complex geological history, to map its enigmatic magnetic field, and to gain insights into the nature of its deep, mysterious core, among countless other quiet questions. This tiny, resilient probe was designed to be our ears, our eyes, and our very senses in a place too extreme for human presence, a silent emissary carrying our collective yearning for knowledge into the heart of the solar system. The story of Messenger is not just a tale of technology, but a testament to the quiet patience and unwavering spirit of scientific inquiry. For decades, the challenges seemed insurmountable, a cosmic wall blocking our path to understanding this closest yet most elusive of inner planets. But the seed of an idea sown by a brilliant mind slowly blossomed into a grand voyage, a carefully orchestrated dance through the solar system, culminating in a prolonged, intimate study of Mercury. It reminds us that sometimes the greatest leaps in discovery come not from brute force, but from elegant thought, from finding the subtle, clever pathways that the universe in its boundless wisdom sometimes reveals. It's a whisper of possibility, a promise that even the most formidable barriers can be overcome with persistent curiosity and a touch of ingenious design. As we contemplate the incredible hurdles that had to be overcome to even get to Mercury, we can truly appreciate the magnitude of this mission. It wasn't just about building a robust spacecraft. It was about reimagining the very journey, finding a way to bend the powerful forces of the solar system to our will, not through brute force, but through a delicate and intricate understanding of cosmic mechanics. Chen Wangyan's insight was a whisper in the vastness, a revelation that changed the course of planetary exploration. She saw the planets themselves as tools, not just destinations, each one a cosmic slingshot, a gentle break, a helper in a larger, more complex journey. The choice of Messenger's size and weight reflects the profound discipline required for such missions. Every gram saved on fuel could be a gram allocated to a spectrometer, magnetometers and imager, instruments that would transform Mercury from a distant blur into a richly detailed world. It was a conscious decision to prioritize knowledge, to maximize the scientific return, even if it meant a smaller, more specialized craft. This careful balance, this meticulous planning, is a quiet testament to the dedication of the scientists and engineers who breathed life into this mission, who saw not just a machine, but an extension of human curiosity, a quiet explorer on a grand quest. And as we conclude this chapter, let us hold in our minds the image of Messenger, a tiny, resilient voyager, clothed in armor against the sun, embarking on its long, patient pilgrimage. It is a symbol of our unending desire to understand, to gently peel back the layers of mystery that shroud our cosmic neighbors. Its journey was not just a flight through space. It was a testament to the power of a single brilliant idea, nurtured by years of patience, leading to an unprecedented rendezvous with the sun-kissed enigma that is Mercury. The silence that followed Mariner 10 was not an end, but a deep breath, a quiet gathering of strength before humanity made its most profound attempt to truly know the first planet. Our journey with Messenger, our brave little emissary to Mercury, now truly begins. After its meticulous construction and a long period of quiet anticipation, the probe's path through the solar system was a testament to the patient artistry of orbital mechanics. Messenger spent its very first year in space, making a single graceful orbit around the sun before meeting back up again with Earth. This wasn't merely a scenic detour. It was a crucial testing phase, a gentle rehearsal on a known cosmic stage. This gave the tireless scientists a precious chance to thoroughly test all of Messenger's delicate equipment on a familiar astronomical body, our own home planet and its loyal moon. They could meticulously check for any hidden errors, listen for any faint dissonances in its operational hum, and make any necessary adjustments to ensure that when it faced the true furnace of Mercury, every instrument would sing in perfect harmony. During this early phase, Messenger with its nascent vision captured some initial photographs of Earth and our moon. These images, though simple, were profound. A distant self-portrait of our collective home seen through the eyes of a machine destined for a far harsher realm. It also quietly tested its other equipment, diligently, taking readings of our own atmosphere and magnetosphere, verifying its senses, ensuring everything was working perfectly, before venturing into the truly unknown. Fortunately, every component, every delicate sensor performed flawlessly, a silent promise of the discoveries to come. As Messenger began to head further sunward, a delicate and clever technique was employed to help reduce its relentless acceleration towards the sun. Imagine, if you will, the sun's radiant energy as a constant, gentle breeze, unseen yet powerful. Messenger used its 2 solar panels typically designed to capture sunlight for power, to also catch this solar radiation like sails on a ship might catch the wind. It's a subtle force, almost imperceptible to us on Earth, but solar radiation hitting an object actually pushes it ever so slightly. While this force is indeed incredibly tiny, a mere whisper in the vastness, because Messenger's journey was so incredibly long, Stretching over billions of kilometers, this constant gentle push really added up. Making the most of this subtle phenomenon was one of the ingenious ways Messenger saved precious propellant, allowing it to decelerate naturally, a slow, graceful braking maneuver performed by the sun's own light. The next notable landmark in Messenger's intricate journey came quietly in 2006 when it performed its first flyby of Venus. Sadly for the scientists, this moment occurred at a peculiar conjunction. Venus was exactly on the opposite side of the Sun from Earth. This meant that Messenger was temporarily out of radio contact with its human companions, a brief period of silent, independent flight. While it did manage to capture some photographs of the planet, which it later sent back to Earth, it otherwise performed no direct scientific observations during this particular encounter. It was a fleeting, unobserved kiss in the cosmic dance. However, a year later in 2007, Messenger passed Venus again, a second, more intimate encounter. And this time, a beautiful cosmic collaboration unfolded. At that very moment, another spacecraft, ESA's Venus Express, was already gracefully orbiting Venus, diligently studying our veiled neighbor. Messenger and Venus Express seized this rare opportunity to work together, performing the first ever simultaneous measurements of the particle and field characteristics of the planet. Imagine two distant ears listening to the same subtle whispers of Venus's environment, their combined data painting a richer, more comprehensive picture. It was a quiet symphony of science, two probes harmonizing across the vastness. But then after these preparatory dances, it was on to the main event, the ultimate destination, Mercury. Messenger made its first flyby of Mercury on the 14th of January 2008. All systems purred in perfect synchronicity. Everything went smoothly, a delicate, flawless execution. The same quiet success marked its second flyby of Mercury. These initial close approaches were crucial, not just for gathering initial data, but for fine-tuning the probe's trajectory, gently shaping its path for its ultimate capture into Mercury's orbit. However, during the third flyby in 2009, a ripple of unexpected tension coursed through the mission control. Something went awry. Messenger, in a sudden, unsettling turn, went into safe mode. This protective state is designed to shield critical systems on the craft in the event of an error. A digital guardian angel safeguarding its precious cargo. Imagine the profound disappointment, the sudden surge of anxiety for the countless scientists who had poured their lives into this mission, who had come so incredibly far, only for the mission to potentially stumble during one of its final, most critical stages. The silence in mission control must have been thick with unspoken worry. Messenger remained in safe mode for what must have felt like 7 agonizing hours, a period of immense stress for all the dedicated scientists involved. The cause of this unexpected pause lay in a particular challenge. During that flyby, Messenger had to pass through Mercury's shadow, a brief period of total eclipse where the sun's direct light was completely blocked. This meant that for 18 crucial minutes, the probe had to rely entirely on its internal batteries for power, its solar panels momentarily useless in the profound darkness. It turned out that something wasn't configured quite right in the power management part of the software, a subtle glitch in the digital brain. Fortunately, in a moment of quiet relief, Messenger's computer performed a self-reset. Once power from its solar panels re-exposed to the sun's embrace recharged the battery. With a silent sigh of triumph, the brave little probe was able to continue with its mission, swinging around the sun one more time, making its final careful adjustments before finally entering its elliptical orbit around Mercury on the 11th of March, 2011. It was a culmination of decades of dreams, a silent promise finally fulfilled. Once gracefully captured by Mercury's subtle gravity, Messenger took up a unique elliptical orbit, a cosmic breath-in, breath-out dance. It alternated between drawing as close as a mere 200 kilometers to the scorching surface and then swinging far away to a distance of 15,000 kilometers. This unique dance was a brilliant strategic move designed to protect the delicate craft from the intense heat. Imagine Mercury acting like a giant, shimmering mirror, radiating the sun's ferocious heat back into space. Remaining too close to Mercury for extended periods was simply too hot for Messenger, even with its specially designed heat shield, which was more precisely crafted to protect it from the direct blinding glare of the sun, 7 times brighter by Mercury than it is on Earth. So by moving further away every 12 hours, Messenger was given a vital chance to cool off to dissipate the accumulated heat, preparing itself for its next close pass. It was a rhythmic breath drawing near and pulling back from the radiant mirror, a silent, carefully choreographed survival dance. Messenger, with its quiet determination, spent the next 4 years in Mercury's orbit. This far exceeded the initial hopes and expectations of the scientists who had originally planned for the mission to last only a single year. It was a silent triumph, a perseverance beyond all hopes, a quiet gift from a resilient machine. Before its launch, scientists had hoped that Messenger would take at least 1,000 photographs over the course of its lifetime, a modest ambition given the challenges. However, the probe in its tireless dedication surpassed all wildest dreams. It captured over 200,000 photographs, a vast and unprecedented visual treasure trove. This incredible collection gave us a complete map of Mercury's entire surface, rendered in breathtaking high resolution, and even in color. Beyond its primary target, Messenger also gently turned its gaze to nearby comets and other planets, capturing fleeting images of distant cosmic beauty. A silent photographer documenting the silent dance of the solar system. On the 25th of December 2014, a quiet, almost mournful milestone approached. Messenger's precious propellant, so carefully conserved and strategically used until that point, was finally about to run out. By this poignant moment, Messenger was orbiting a mere 25 kilometers from the surface of the planet, its closest, most intimate embrace yet. In a final act of quiet determination, scientists gave the thrusters one last gentle burst, a final sigh of effort to extend its orbital life for as long as humanly possible, squeezing every last drop of precious fuel. But on the 30th of April 2015, after a journey that had lasted over a decade and had gracefully covered literally billions of kilometers, Messenger gently, quietly crashed into the surface of Mercury. Its long, arduous journey had come to its peaceful end, a silent farewell, as it returned to the very dust it had sought so diligently to understand. It was a final, humble return, a part of its silent subject. Messenger, in its quiet, diligent service, bestowed upon us a wealth of profound insights into Mercury before its graceful demise. On board this remarkable craft were a host of sophisticated scientific instruments, each an extension of our senses. Among them was a magnetometer specifically designed to map out Mercury's enigmatic magnetic field. This field, though weaker than Earth's, is thought to be generated by a dynamo effect within its molten core, a swirling dance of liquid metal deep within the planet's heart. Here on Earth, our rapid rotation and the gentle, persistent tug of our moon's tidal stretching help to keep our own core molten, a churning engine of our planet's magnetic shield. But Mercury, in its solitary existence, doesn't possess a moon, nor does it have a particularly fast rotation. What it does possess, however, is that remarkably eccentric orbit, more pronounced than any other planet. This eccentricity means that as Mercury gracefully dances around the sun, the gravitational strength exerted upon it subtly increases and decreases as it gets closer and further away. So the sun's tidal forces, like invisible hands, constantly pull and squeeze on the planet. The constant friction generated by this subtle, rhythmic deformation. This gentle cosmic kneading is believed to be what keeps Mercury's deep core, hot and molten, perpetuating the dynamo effect and maintaining its fragile magnetic field. It is a cosmic squeeze keeping the inner fire alive, a testament to the powerful unseen forces at play. Unlike Earth's magnetic field, which is generally centered within our planet, Mercury's magnetic field is curiously offset from the center by about 20% of the planet's radius. And this remains a beautiful, intriguing mystery. We don't really know why. This is a subtle asymmetry in its invisible shield, waiting for future whispers of discovery to reveal its secret. As we've noted, its magnetic field is only about 1% as strong as Earth's a humble shield compared to our mighty guardian. Yet even this gentle strength has a profound impact, deflecting a significant portion of the solar wind around the planet, protecting its fragile exosphere. However, due to its intimate proximity to the Sun, the solar wind pressure around Mercury is far, far greater than it is around Earth. Imagine a relentless, unseen cosmic current pressing down with immense force. Add to this relentless pressure Mercury's inherently weak magnetic field, and the result is a magnetosphere around Mercury that is compressed closely to the planet's surface. Earth's, on the other hand, extends many times the diameter of the planet away from the surface, a vast protective bubble. Interestingly, these very factors combine to make the magnetosphere of Mercury highly dynamic. What does this profound dynamism entail? Well, for one, reconnection events are astonishingly common, occurring 100 times more frequently around Mercury than around Earth. Imagine magnetic field lines, like invisible threads, stretched taut by the solar wind suddenly snapping together as the charged solar wind pushes against the planet's magnetosphere. When this happens, it creates a momentary breach, allowing a few of these energized, charged particles to break into the planet's magnetosphere, briefly entering a region of plasma in the planet's magnetotail before being swept away. The delicate flows you see in scientific simulations in the plasma region are the ethereal traces of these very reconnection events, a silent crackle in the void. Another fascinating feature of this dynamic magnetosphere that MESSENGER detected was the presence of energetic bursts of electrons, invisible whispers of power, radiating through the cosmic expanse. These bursts produced hundreds of thousands of electron volts of energy. As MESSENGER gracefully orbited Mercury, it picked up thousands of these remarkable events, listening intently to the planet's subtle energetic symphony. Mysteriously, these powerful bursts were mainly localized in the northern hemisphere and appeared to be compressed towards the planet along the sun-facing side. This remains an ongoing field of quiet study, a beautiful puzzle that scientists continue to ponder, a silent challenge to our understanding. However, the gentle speculation suggests that these electrons have been accelerated through breakdowns in the magnetotail, then gracefully follow the direction of the magnetic field flowing from the South Pole to the north, a silent river of energy coursing through Mercury's unseen shield. The more we learn about this compact, sun-kissed world, the more its subtle complexities reveal themselves, inviting us to wonder at the intricate workings of the cosmos, even in the smallest of its children. Its stillness is an illusion, for within and around it, a silent, powerful dance of forces continuously unfolds. As we delve deeper into the quiet revelations that MESSENGER so patiently gathered our attention, now turns to the very breath of Mercury, its subtle exosphere, and the surprising richness of its ancient surface. MESSENGER hosted a wide array of spectrometers, those silent, discerning eyes that can unravel the very composition of distant worlds. Spectrometers are immensely important tools for detecting the intricate composition of mineral deposits on a planetary surface without ever having to take a physical sample. Imagine them as cosmic alchemists, discerning the elemental ingredients from afar. These remarkable instruments can also be used to gently detect the particles that drift within a tenuous atmosphere, listening to the subtle chemical whispers in the void. Now, as we've quietly discussed, Mercury doesn't possess a true atmosphere in the way we experience it on Earth, that thick, enveloping blanket of gases. But it does, as previously mentioned, have an exosphere, an extremely tenuous, almost invisible veil surrounding the planet. It is so incredibly thin that the individual particles within it rarely, if ever, interact or collide with each other. Yet what MESSENGER discovered about this exosphere's intimate relationship to the surface truly surprised the scientists. Like an unexpected melody in a familiar tune, Mercury, it turns out, is not just a fried, barren, rocky planet. Its surface, to the quiet astonishment of the scientific community, is covered with volatile substances. Imagine a hidden palette of vibrant elements far from a mere uniform scorched rock. Messenger found it to be surprisingly rich in potassium, magnesium, sulfur, sodium, and chlorine at levels far higher than any other terrestrial planet and much, much higher than on our own moon. This profound discovery that Mercury's volatile ratios shared more in common with distant Mars than with our immediate neighbors, Earth and Venus, completely overturned many prevailing solar system formation theories that existed before Messenger gracefully arrived at Mercury. It was as if an ancient story long accepted was suddenly rewritten, a new truth unveiled by the silent data, forcing us to rethink the very beginnings of our cosmic home. These delicate volatiles on Mercury's surface are constantly being blasted by the relentless radiation from the sun, a ceaseless, unseen cosmic wind. This process occurs more intensely at the equator than near the poles, a subtle, invisible force painting patterns of loss and abundance across the planet's face. This may gently explain why, on the surface, some substances like potassium are found to be more abundant in the northern hemisphere than around the equator. It is simply much hotter on Mercury around the equator than at the poles, so the potassium there would have been heated enough that much of it has been lost from the surface, sublimating away into the exosphere, a silent evaporation under the sun's fierce gaze. And the exosphere itself contains many of the very same particles you would also find on the surface, sodium, potassium, and the other volatiles we mentioned. This exosphere, as we've noted, is far from stable, a delicate balance poised on the edge of loss. The solar wind, that constant stream of charged particles from the sun, ceaselessly picks up and carries away many of the charged particles from the exosphere. And the subtle pressure of solar light also gently pushes away many of the neutral particles. Were it not for constant underlying processes that perpetually replenish the exosphere, Mercury would, in a relatively short cosmic time frame, lose it all to the vast emptiness of space, its delicate veil dissolving completely. While most of these substances certainly originate from the planet's surface blasted off by micrometeorite impacts or solar wind, the exosphere also contains other mysterious elements that cannot be found there, specifically hydrogen and helium. So a quiet question naturally arises: where did they come from? Well, as you might know, our sun, that magnificent furnace, is made predominantly of hydrogen and helium. And in a beautiful cosmic interaction, the solar wind itself carries these very particles to Mercury. Some of the solar wind, in its relentless journey, actually gets caught up in Mercury's tenuous exosphere and lingers there for a while, a fleeting visitor. As far as our current understanding reaches, this is the only major source of hydrogen and helium in Mercury's exosphere, a silent testament to the sun's constant pervasive breath. In the images captured by Messenger's patient eye, we see fascinating glimpses of these atmospheric dynamics. Calcium, for reasons still unknown and awaiting further quiet investigation, is much more prevalent in the exosphere during the planet's dawn than during its dusk. And we see magnesium gracefully streaming away from the night side of the planet, an ethereal ribbon of light. In fact, Mercury's tail, that ghostly comet-like whisper, has been known about for a while. In these luminous images, sodium ions are lit up as they stream away from the planet, making Mercury, with its subtle glow, look remarkably like a comet itself, leaving a luminous trace in its wake. Incredibly, if you were to look up into the night sky on Mercury, that profound darkness pierced by countless distant stars, you would actually see a faint yellow glow. It is a sight reminiscent in a strangely comforting way of city lights here on Earth, a subtle luminescence against the black. This tail, however, is not constant. It is seasonal, a changing cosmic banner. Mercury's eccentric orbit means that its distance to the sun varies throughout its year, and as it gracefully orbits, its orbital speed also subtly changes. So the time of greatest sodium emission, the brightest glow in its tail, is actually when Mercury is at its middle distance from the Sun, a delicate balance in its cosmic dance. There was one other curious substance found to the quiet astonishment of scientists in Mercury's exosphere water vapor. This was a profound, unexpected whisper from a world seemingly too hot for water. This water vapor could potentially come from the tails of comets as they passed by, leaving behind a trace of their icy essence. Or more intriguingly, it could come from the very ice deposits that MESSENGER detected around the planet's poles. Surprisingly, water ice can indeed exist on this seemingly scorched planet, but only under very specific sheltered conditions. It is found at the bottom of permanently shadowed craters, forever protected from directly interacting with the sun's relentless light rays. Imagine these as veiled sanctuaries of ice, hidden in perpetual twilight, untouched by the searing daytime heat. The Earth-based Arecibo radio telescope had already years prior detected highly reflective regions around the poles, hinting at these hidden icy realms. And as the pristine images from MESSENGER came in these highly reflective regions, perfectly matched up with areas of permanent shadow at the bottom of large craters, confirming the whispers of distant radio waves. Estimates quietly put the amount of water ice found on Mercury at a staggering quadrillion kilograms. While this isn't a colossal amount by Earth standards, a planet teeming with liquid oceans, it would be a significantly vital boost to any future human colony there to have such a vast accessible reservoir of precious water. It is a silent, hopeful promise in the heart of the inferno. Beyond the subtle dances of its exosphere and the surprising discovery of ice, MESSENGER also revealed some other truly surprising features found directly on Mercury's surface. Tiny, mysterious formations, which scientists have named hollows, were found dispersed all over. These are a truly unique feature to Mercury, unlike anything seen on other terrestrial planets. While we are not yet completely sure what causes them, the gentle speculation suggests they may be volatile substances sublimating directly from the surface, turning from solid to gas under the sun's fierce yet indirect influence. Their uniqueness to Mercury is simply due to the planet's intense proximity to the sun, which creates the very conditions necessary for such subtle geological processes. They seem to be an active geological process, appearing to be some of the youngest features on the planet, suggesting that Mercury, despite its ancient stillness, still undergoes quiet, subtle transformations. Crucially, they are certainly not the result of meteor impacts. Their formation is far more enigmatic, a quiet, ongoing mystery. There is much more going on Mercury's surface than first meets the eye. MESSENGER, with its patient gaze, revealed ancient, dried-up lava flows, silent evidence of immense volcanic activity from eons past. It captured images of vast craters from massive asteroid strikes that warmed its surface to melting points. And surprisingly, it revealed the thin scars, those delicate scarps we spoke of earlier, that were quiet evidence of its gradual cooling. These scarps clearly show that Mercury is indeed contracting. From MESSENGER's precise data, it was determined that Mercury has contracted by over 14 kilometers in diameter. Since its formation, a much greater shrinkage than was previously expected. It is a slow, gentle sigh as it cools and settles its ancient skin, wrinkling in the process. All these profound findings have thrilled the community of scientists, opening new windows into the history and dynamics of the inner solar system. Yet even though we would barely know anything about Mercury, were it not for MESSENGER's incredible quiet sacrifice, somehow this mission isn't that widely known among the general public. It remains an unsung hero, a quiet triumph in the annals of space exploration. Perhaps ESA's Bepi Colombo mission, already on its long patient way to Mercury right now, and due to arrive in 2025, will better capture the public's imagination, bringing the quiet wonders of this sun-kissed world into broader awareness when it finally takes up its silent vigil. As we conclude this contemplation of MESSENGER's incredible legacy, we are left with a deeper, more nuanced understanding of Mercury. It is not a static inert world, but a dynamic, subtly changing body, holding ancient secrets in its very composition, its fleeting exosphere, and its scarred yet active surface. The data whispered back by Messenger has transformed our perception of this seemingly simple planet, revealing layers of complexity and wonder that continue to challenge our theories and ignite our curiosity. It reminds us that even in the most extreme environments, life, or at least the echoes of profound processes, finds a way to leave its subtle, fascinating mark. The journey of discovery is a continuous unfolding, a gentle peeling back of layers. Messenger, through its remarkable resilience and the ingenuity of those who guided it, gave us an unprecedented look at a world that once seemed almost unreachable. Its data is a gift, a silent library of information, inviting us to spend countless hours sifting through its pages, uncovering new whispers, and finding new connections. The beauty lies not only in what we have learned, but in the vastness of what still remains unknown, the questions that continue to beckon us deeper into the mysteries of Mercury. Let us gently turn our thoughts to a time even more distant, when Mercury, this sun-baked sentinel, might have been a crucible of fire and molten rock. We ask an important, almost poetic question: what happens when a planet melts? For Mercury, this is no idle question, but a profound inquiry into its very genesis. At the risk of it being understated, Mercury is, and always has been, a very hot planet. With daytime temperatures reaching an incredible 430 degrees Celsius, a heat comparable to some wood-burning fires, the rocks and dust on Mercury's surface bake beneath a blistering heat that pushes them to their very limits. While it does not hold the crown for the hottest planet in our solar system, that honor perhaps surprisingly goes to Venus, thanks to its thick, insulating atmosphere. Mercury certainly dwells among the hottest, a world perpetually warmed by its radiant neighbor. The Mercury we know today has in fact cooled considerably over the eons. We've gently touched upon the ice at its polar caps, those veiled sanctuaries of frozen water, a testament to areas untouched by the sun's direct fury. And we have observed the subtle signs on its surface, those delicate scarps like wrinkles on an old face, that clearly show it has contracted over time as its interior became colder, a slow, gentle sigh as it settled into its present form. So, what was it like back then in those fiery, nascent days? What stories did its young molten heart whisper? When rock is heated sufficiently, its solid, rigid structure begins to break down, and it transforms into a gloopy, viscous liquid known as magma. Imagine a fluid thick and slow-moving, with a viscosity or runniness tens of thousands or even 100,000 times more viscous than water. For a familiar point of reference, this is a viscosity quite similar to that of thick tomato ketchup, although one would certainly not recommend pouring this molten concoction on your food. Depending on the specific type of rock, magma typically forms at temperatures of at least 600 degrees Celsius, but potentially as high as 300 degrees Celsius. So for Mercury to have begun to melt, to have its very foundations transformed into this fiery liquid, we know with quiet certainty that it must have reached at least these incredible temperatures, its very essence becoming a flowing, glowing river, despite being vastly less runny than water lava, which is magma that has erupted onto the surface, can still travel for great distances before finally stopping its fiery journey. This is due to a fascinating property. Once the very top surface of the lava flow hardens and cools, it forms a protective, insulating layer. This hardened crust acts like a blanket, keeping the rest of the lava beneath it hot and fluid, allowing it to continue flowing freely across the landscape for considerable distances. Imagine a slow-moving river of fire, its surface solidifying, yet its heart remaining molten, relentlessly pushing forward. How do we know this profound process happened on Mercury, this world of silent ancient scars? The quiet clues can be found etched within its vast craters, like the one known as Ladi. Scientists gently estimate that Raditladi is a relatively young crater in cosmic terms, likely under 1 billion years old. It boasts well-preserved walls, standing proud against the ravages of time, and a floor that is remarkably clear of other later impacts. It is a grand basin over 25 kilometers in diameter, a significant mark upon Mercury's face. Now notice a curious contrast, how rough and rugged the hills appear around the crater, their ancient broken forms bearing witness to countless impacts. And yet inside Raditladi, the floor is a strikingly smooth plain. This is no mere coincidence. It is a profound whisper of Mercury's molten past. Originally, the terrain inside Raditladi was likely about as rugged and chaotic as the hills that now surround it, a jumbled landscape of shattered rock. So why, we might gently ask, is it so smooth now? The quiet answer lies in the ancient flow of lava. When lava in its liquid embrace is left on its own, it will naturally try to form the flattest possible surface, just as water does if you pour it into a basin pulled down smoothly under the relentless effects of gravity. The same powerful yet gentle principle unfolded here. An asteroid, a messenger from the depths of space, crashed violently into the planet's surface, carving out the immense basin. And then, in the aftermath, the crater quickly filled with molten lava. Once this fiery liquid cooled and solidified, it formed the beautifully smooth plain we observe today, a silent testament to a world reborn from fire. But where we might gently ponder, did this vast outpouring of lava come from? Here, the scientific community holds two quiet theories, each offering a glimpse into the forces that shaped Mercury. The first suggests that the immense impact of the meteor acted as a trigger, initiating a creeping volcanic eruption. Magma, hot and restless from beneath the surface, slowly rose up through the newly formed cracks and fissures like ancient blood welling from a wound to fill the vast basin. It was a wound that healed with fire. The second explanation offers a slightly different yet equally compelling perspective. It posits that the surface within the crater simply became so intensely hot due to the sheer energy of the meteor's impact that it pushed the already superheated rock crust over the tipping point, causing it to melt directly in place. This particular kind of lava, born directly from the immense energy of a cosmic collision, is known as impact melt. The true explanation, as is often the case in the universe's grand narratives, is likely a quiet combination of both a powerful interplay of external force and internal fire. Now that we understand that a profound smoothness is a telltale sign of past lava flow, a signature left by ancient rivers of fire, we suddenly realize that there are numerous other craters on Mercury that similarly must have been filled with lava. Just look, for instance, at the crater Rostelli, where crags of ancient mountains can still be seen, poking up like islands in a solidified sea through the smooth, unblemished lava layer. Or consider Copland, a silent testament to similar fiery inundations. And Rachmaninoff, a truly intriguing example. In Rachmaninoff, you can clearly see strong indicators of lava bubbling up from beneath the surface, reaching the very center of the crater. Take a moment to observe the strange crinkled cracks forming a rough circle inside the central crater. Such intricate features are a quiet signal that a slower, more deliberate outpouring of magma pushed up from beneath the surface, gently breaking the newly formed plain, then pushing up further and finally cooling again under the dramatic effects of Mercury's wildly fluctuating temperatures. Here and in many of these impact craters, the collisions from space did not just leave scars. They triggered deep, powerful volcanic activity from within Mercury's ancient shell, a testament to the planet's fiery responsiveness. But the rivers of lava, those silent, glowing flows, did not merely confine themselves within the circular basins of craters. They also spilled out across the wider landscape, shaping vast regions of the planet. Let us now look at a valley known as Angkor Vallis. Here, you can observe clear, unmistakable signs of smooth lava flow, but this time it moves like a majestic river carving its path across the terrain. This molten river of fire traveled from higher ground to lower ground, a relentless fiery current, until it eventually poured into the vast basin next to it. Flows like these, vast and inexorable, ended up filling massive seas, taking up enormous swaths of the planet, and transforming their original appearance into the more orangey color we observe today. Scientists, with their keen eyes and patient observation, have begun to recognize this telltale orange color as a sure sign of ancient volcanic activity, a subtle palette revealing a powerful past. And from these quiet observations, a more detailed picture has begun to emerge of conditions on early Mercury, painting a vivid, though perhaps even less hospitable portrait. Areas like the one to the northeast of Rachmaninoff are very likely formed by profound volcanic activity. When Messenger gracefully flew over this specific area in 2015, its sophisticated cameras captured detailed photographs revealing a surface covered in a fine powdery dust. Upon careful review, the nature of this dust became obvious. It was volcanic ash that must have erupted from unseen vents, firing out into the tenuous sky and gently covering the terrain around it. NASA scientists, in a moment of quiet poetic insight, likened it to snow, but a fiery, hot, angry snow descending from a tumultuous sky. So on early Mercury, it wasn't just vast rivers of lava flowing beneath your feet that you would have had to contend with. Imagine burning ash falling from the sky, a silent, scorching snowfall. And that was just from the calmer, more effusive volcanoes. The final, most dramatic indicator of profound volcanic activity on Mercury hints at eruptions so destructive, so immensely powerful, that entire chunks of the planet itself were literally scooped out. Let us take a quiet look at the crater known as Navoy. This, dear listener, is no mere impact crater. When a crater is formed by a celestial body striking a hard surface, one that is not sufficiently hot to melt into lava, a distinct central peak is usually formed. Imagine the mechanics when the crater walls suddenly find themselves exposed after the impact gravity, that relentless invisible force, suddenly exerts itself on all that loose particulate matter. This material rushes down the walls of the newly scooped out basin, accelerating towards the center. Once there, having built up considerable momentum, it crashes violently into all the rocks and landslides that are simultaneously sliding down from the other side of the crater. The two sides meet with immense force, and all that momentum and energy force them to keep moving in the only direction they can, upwards. You can observe the same effect, perhaps more clearly, when you throw a large rock into water. The water of the newly formed basin rushes in to fill the gap, but then crashes into water from the other side, and all of it shoots upward in a powerful secondary splash. But unlike water, the sand and loose rock of a crater does not level out. Instead, it forms that distinct central peak. Depending on the angle at which the meteor impacted, this peak can be either perfectly rounded or possibly teardrop-shaped. However, the curious central formation within Navoy is neither of these things. As scientists meticulously examined this feature, they came to the quiet yet profound conclusion that this crater was not formed by an impact at all. Instead, it had been carved out through the sheer explosive force of an erupting volcano. At 66 kilometers in diameter, the amount of force exploding upwards from within the sheer power necessary to carve out this colossal crater and scatter its remnants for kilometers all around must have been truly massive, an unimaginable display of planetary fury. So there you have it, the whispers from Mercury's past, painting a vivid, albeit hellish picture of its fiery youth. Imagine meteors raining from the sky, their impacts so profound they tipped the rocks they landed on over their melting point, creating seas of fire. Volcanoes bursting forth, either slowly filling the landscape with bubbling magma in vast lakes and fiery rivers, or choking the tenuous air with burning ash. Not that there was any breathable air to begin with beyond the thick toxic gases emitted with these violent eruptions. And even the ground you might have attempted to stand on could at any given moment explode beneath your feet. This is the silent, fiery narrative of what it was like when a planet was melting When Mercury was a true furnace of creation and destruction, Mercury is quiet now, a world of settled fires. As near as we can tell, there are no longer any active volcanoes on the planet. Though the sun still bakes down upon it with relentless intensity, the unbridled fury that once raged beneath its surface is now calm and soothed. Yet for all those who know how to look, who listen for the quiet echoes of its past, the profound evidence of what once was is still there, locked in the very geological record of its surface. It is the scars, the subtle wrinkles, the vast plains of solidified fire that tell the compelling story of a violent yet ultimately transformative past. Our quiet journey through the solar system now brings us to Venus, a world often called Earth's sister planet, or twin, yet one that reveals profound differences as we gently pull back its veil. From afar, Venus shines brilliantly in our sky, often mistaken for a star, a beacon of elegance and serenity. It carries the name of the Roman goddess of love, Venus, and indeed from an outsider's perspective, cloaked in soft, shimmering clouds like a blanket, it's easy to see why it inspired such poetic associations. Its surface appears seemingly calm and almost tranquil, hinting at a gentle, serene world. But let us dare to go beneath that alluring cloud layer, to pierce through the shimmering veil, and you'll find quite the opposite. The tranquil facade gives way to a brutal reality. Instead of gentle breezes, you would encounter scorching temperatures hot enough to melt, lead relentless volcanism reshaping its ancient face, and a crushing atmosphere that would flatten any unprotected visitor. It is an environment of profound hostility, a place where acid-laced rains evaporate before even touching the ground, making any visit next to impossible for human life. So what do we truly know about this beautiful yet hellish planet? More perhaps than you might think, thanks to the persistent curiosity of our probes, those silent, brave emissaries that dared to venture into its fiery embrace. Let's begin by simply stepping back a bit, allowing our minds to settle to see where this formidable planet fits into the grand tapestry of our solar system. Venus is the second planet from the Sun, a celestial neighbor nestled between Mercury's fiery dance and Earth's vibrant blue. It is our closest planetary neighbor, drawing nearer to us at times than any other world. Its average orbital radius around the Sun is about 0.72 astronomical units, which roughly translates to 108 million kilometers. What's particularly interesting about Venus's orbital journey is its remarkable consistency. It doesn't vary much at all from this mean orbital radius, as it boasts the least eccentric orbit of all the planets. Imagine a dancer moving in a nearly perfect circle around the central fire, a graceful, almost flawless cosmic ballet. At Venus's closest approach to us, it truly earns its title as our closest planetary neighbor, being only 41 million kilometers away. Yet, in a curious paradox, this is not when it appears brightest in our night sky. When it is closest to us, it positions itself between Earth and the Sun, meaning we primarily see its dark night side, much like the new moon. However, its brilliant visibility persists even then, as the sunlight remarkably refracts through its thick atmosphere, casting a faint glow. It is actually at its brightest when it appears as a thinner crescent shape in our sky, a sliver of light illuminating the heavens. And when this happens, it becomes the brightest object we see at night after the moon, a radiant jewel that has captured human attention for millennia. As such, Venus is commonly, though mistakenly, reported as an unidentified flying object. Even U.S. President Jimmy Carter reported having seen a UFO in 1969, which later analysis gently suggested was almost certainly Venus shining with its startling ethereal brightness. Countless other people throughout history have mistaken this radiant celestial body for something more exotic due to its overwhelming luminescence, a silent testament to its captivating power. Recently, I had the quiet pleasure of looking at Venus through a telescope, and remarkably, the crescent shape of it was very visible, a delicate curve of light in the vast darkness. With Venus orbiting so intimately between us and the Sun, it might lead one to wonder if Venus ever eclipses the Sun from our unique viewpoint on Earth. And the quiet answer is yes, but surprisingly, very rarely. These rare celestial events are known as transits, and they happen in pairs. Each pair is separated by about 8 years, but here's the truly remarkable part. These pairs of transits only occur roughly once every 100 years or so. The last transit we were fortunate enough to witness was in 2012, a fleeting cosmic spectacle. But if you happen to miss that rare celestial ballet, I'm afraid the next one won't grace our skies until 2117. It is a profound reminder of the vast stretches of cosmic time that govern such alignments. The reason for this profound rarity lies in a subtle yet crucial detail. The orbiting plane of Venus is not exactly the same as Earth's. Imagine two delicate, invisible cosmic sheets, each representing a planet's orbital path, gently tilted relative to each other. They only intersect at very specific points. Additionally, Venus only catches up with Earth reaching a similar alignment approximately every 584 Earth days. These two quiet factors combined ensure that while a transit of Venus is a spectacular and predictable sight, it is also a profoundly rare one, meaning most of us will likely only ever have the chance to witness it once or twice in our lifetimes, a true cosmic privilege. Now let us turn to Venus's internal rhythm, its rotation. All the other planets in our solar system gracefully orbit anti-clockwise around the Sun, and in this, Venus is no different. But here is where Venus reveals its unique, rebellious spirit. Unlike all the other planets, it rotates clockwise, or in other words, in a retrograde rotation. Imagine a lone dancer spinning against the grand sweeping current of the cosmic flow. Not only does it spin backwards compared to its siblings, but it also possesses an extremely slow rotation, the slowest of any planet in our solar system. It takes a remarkable 243 Earth days for Venus to complete just one rotation around its axis. This makes a sidereal day on Venus, the time for one full rotation, actually longer than a Venusian year, which lasts a mere 224 Earth days. Imagine a day that stretches beyond a year, a curious twist of cosmic time that challenges our very perception of planetary motion because of this unique retrograde rotation. However, a solar day on Venus, the time from one sunrise to the next sunrise, is considerably shorter at about 117 Earth days. This means you would experience just less than 2 days on Venus in one Venusian year, a profoundly different rhythm from our familiar earthly cycle. To truly give you some perspective as to how incredibly slowly it rotates, imagine standing at Venus's equator. The planet there is only rotating at a gentle speed of 6.5 kilometers per hour, a leisurely stroll compared to Earth's rapid spin. This remarkably slow rotation has another fascinating consequence. It makes Venus the second most spherical object in the solar system after the Sun itself. Imagine a perfectly smooth pearl spun by the gentlest, slowest hand, its form almost perfectly unblemished by centrifugal forces. The reason why Venus rotates backwards against the collective cosmic current of its planetary siblings remains a beautiful and intriguing mystery. It's a question whispered by the stars, still awaiting its full revelation. Gentle theories abound. It could be due to a colossal impact with another celestial object billions of years ago, a titanic cosmic collision that literally flipped the young planet on its axis. Or perhaps it's a subtle tidal locking with the Sun, or complex tidal effects on the Venusian atmosphere, gradually nudging its rotation over eons. The universe, in its boundless wisdom, often keeps its deepest secrets close, inviting us to ponder and explore. Despite these profound differences in rotation and atmosphere, Venus shares a remarkable similarity with our homeworld. Its mass and size are very similar to Earth's. This is precisely why it's so often referred to as our sister or twin planet, a cosmic doppelganger in form, though utterly transformed in spirit. Venus is one of the 4 inner terrestrial planets, a rocky world much like ours. Its diameter is slightly smaller than Earth's, measuring about 12,100 kilometers compared to Earth's 12,740 kilometers, and its density is 5.3 grams per cubic centimeter, very close to our own 5.5 grams per cubic centimeter. This close resemblance in mass and density means that the gravity on Venus is only a tenth weaker than that on Earth, a gentle embrace almost as firm as home. Its surface gravity measures 8.9 meters per second, squared a pull that would feel remarkably familiar to a human standing on its fiery surface if only one could endure the other profound challenges. But here, dear listener, is where the gentle similarities end and the stark, uncompromising realities begin. Because on the surface of Venus, the atmospheric pressure is a staggering 92 times greater than that on Earth. Imagine, if you will, the equivalent of being submerged a full kilometer under Earth's deepest oceans, a crushing silent weight pressing down from every direction. The reason for this overwhelming pressure lies in the very nature of Venus's atmosphere. Its density is 93 times greater than Earth's. Try to conceive of fitting that immense amount of gas, that colossal volume of atmospheric material, into a space slightly smaller than what we have here on Earth, and then you can begin to understand why it is so incredibly densely packed, a suffocating blanket woven from unseen forces. The atmosphere itself consists mainly of carbon dioxide, CO2 gas, a primary component in the air we exhale, but in immense, overwhelming concentrations on Venus. And combined with thick, corrosive sulfur dioxide clouds, you are left with the strongest greenhouse effect in the solar system. This runaway greenhouse effect traps heat with relentless efficiency, leading to average surface temperatures of a blistering 462 degrees Celsius, hot enough to melt lead a true cosmic oven. This makes Venus's surface temperature greater than Mercury's, even though Mercury is much closer to the Sun and receives only about 25% of the solar radiation that Mercury does. The profound difference, the cruel irony, is that Mercury has no substantial atmosphere to retain the heat it receives, allowing it to dissipate into space, whereas Venus, with its incredibly dense and thick atmospheric blanket, certainly does. Venus truly is cooking, not just in its day, but ceaselessly. It absorbs so much heat, but then, like a perfectly sealed thermal flask, it retains that heat with extraordinary efficiency, refusing to let much escape. This means that even at nighttime, and remarkably even at the poles, the temperature remains fairly constant, a uniform embrace of heat with no cool respite, no gentle fluctuations. With an axial tilt of only 3 degrees, it also means that seasonal changes in temperature are virtually non-existent. A world without the gentle sway of seasons, perpetually experiencing an unrelenting fiery summer. While the temperatures are extreme, the wind speeds aren't very high on Venus's surface, typically only a couple of kilometers per hour, a gentle crawl compared to Earth's fiercer gusts. However, because of the immense thickness and density of the atmosphere, even these seemingly slow winds apply a remarkably strong force on any obstructions capable of subtly moving small rocks and dust across the surface. Imagine a slow, molasses-like current, yet one with immense pushing power. On the other hand, the wind speed at the cloud layer is a completely different story. Here, the winds are much faster, reaching speeds of up to 300 kilometers per hour. These furious winds at the cloud tops circle the entire planet about every 4 to 5 Earth days, creating an optical illusion that makes the planet look like it's rotating a lot faster than it actually is. A silent, swirling dance of the upper atmosphere. The cloud layer itself sits majestically above the thick carbon dioxide, and it consists mainly of sulfur dioxide and sulfuric acid droplets. Sulfuric acid, just as a quiet side note, is highly corrosive and acid, capable of dissolving many materials. This constant rain of acid just adds to the hellish nature of Venus, though remarkably it does evaporate before it ever hits the superheated surface, turning back into gas before it can complete its descent. These towering clouds on Venus are incredibly reflective, acting like a giant shimmering mirror, only allowing about 10% of the sun's direct sunlight to penetrate through to the surface below. And because they completely cover the entire planet, a perpetual shroud, they entirely obstruct any visual view of the surface from space. This is why our early understanding of Venus's surface remained so elusive. These clouds are also capable of producing lightning, much like on Earth, though it's not as common or dramatic, often appearing as fleeting internal flashes within the perpetual gloom. Recently, a fascinating discovery was made. Venus has a large vortex at its south pole, much like the powerful mesmerizing storms observed on distant Saturn. Now, if you could visually compare them, you would see that Venus's vortex, while vast, is shaped quite differently from Saturn's. And Venus only has one such storm, whereas incredibly, every single black dot in the Saturn image, for instance, represents a separate powerful storm, with the main colossal vortex being in the very center. The vortex on Venus resides at an altitude of 59 kilometers, just above the main cloud deck, a colossal swirling entity in its upper atmosphere. This brings us to an interesting point about the atmosphere of Venus, because at about 50 kilometers up at that particular altitude, the air pressure and temperature would actually be remarkably tolerable by Earth standards. Imagine, if you will, a region where the conditions might almost feel familiar. Even the gravity would feel very much like Earth's, a comforting tug. The only profound problem with a human being physically present there would be the air itself, filled with corrosive gases and lacking breathable oxygen. But if you were to have an airtight plane or some kind of specialized floating habitat, the conditions at this specific altitude would astonishingly actually be very Earth-like, offering a tantalizing whisper of possibility amidst the profound hostility of the planet below. It is a subtle, almost poetic contrast, a pocket of quiet potential in a world of overwhelming extremes. Let us now gently descend further, pushing past the clouds of Venus towards its very surface. For here, a truly remarkable story unfolds, one of pioneering efforts and unexpected glimpses into a landscape long hidden. We actually possess some real photographs of the surface of Venus, thanks to the quiet, brave efforts of the Russians back in the 1960s to the 1980s. These were feats of engineering and resilience, pushing the boundaries of what was thought possible. The Venera 7 probe in 1970 etched its name into the annals of space history as the first probe to ever successfully land on another planet and send back data. Previous attempts by earlier probes had sadly resulted in their signals terminating before touchdown, swallowed by the crushing atmosphere and searing heat. Venera 7. It is believed probably toppled over on impact, a silent tumble onto the alien ground. And so the only reading it could send back was the surface temperature, a scorching 475 degrees Celsius. It was a fleeting whispered report from the very edge of hell, confirming the brutal inferno that lay beneath the clouds. A few years later, Venera 8 gently confirmed another crucial detail, that at the surface, the visibility was surprisingly clear, with a range of about 1 kilometer. This was a significant discovery, as the planet's thick, opaque cloud layers were found to end at quite a high altitude, meaning the ground below was not shrouded in perpetual mist, making it suitable for cameras in future missions. It was a clear, quiet invitation for a visual exploration. Then came Venera 9 in 1975, which sent back the first ever image of the surface of Venus. Imagine the wonder, the profound moment of seeing. For the very first time, the ground of another world painted in unfamiliar hues. Following this, Venera 10, 13, and 14 over the course of 6 years continued this quiet work, sending back more imagery, this time even in color, alongside a wealth of invaluable data regarding the precise conditions of the planet. These were our eyes on a world previously unseen, bravely enduring the unimaginable pressures and temperatures to send back their silent, precious reports. Since then, there have been a number of other probes that have meticulously mapped out the surface of Venus. Using radar, they are able to pierce through the thick cloud cover like invisible light and image the planet's surface in incredibly high definition. This technology, so different from visible light, allows us to truly see what lies beneath that perpetual veil. The surface of Venus, as revealed by these patient unseen eyes, is dotted with a vast number of large, but not necessarily active volcanoes. It boasts an astonishing 167 volcanoes that are over 100 kilometers in diameter. To put this into perspective, the only complex of this immense size on Earth is the sprawling Big Island of Hawaii, a testament to our planet's powerful volcanic forces. This abundance of colossal volcanoes does not necessarily mean Venus is more volcanically active than Earth in the present day. Instead, it speaks to a deeper, more profound difference. Venus possesses a much older crust than our dynamic Earth. Earth, as we know, has plate tectonics, a ceaseless gentle churning of its surface. These colossal plates, like pieces of a cosmic jigsaw puzzle, are constantly moving, bumping, scraping, and pulling apart from one another. This continuous motion allows our planet to release its internal heat efficiently and to renew its surface fairly regularly, with features changing over geological timescales measured in hundreds of millions of years. Venus, on the other hand, seems to lack any form of plate tectonics. Instead, its crust is estimated to be incredibly ancient, about 300 to 600 million years old. This age suggests a profound cataclysmic event in its past. A global resurfacing event likely occurred. The prevailing theory, a quiet whisper from the deep past, is that the mantle beneath Venus's surface heated up so immensely trapped beneath that unmoving crust that it finally forced its way up through the crust, with overwhelming power covering most of the entire surface, with vast flowing seas of molten lava. It was a fiery rebirth, a planetary cleansing by fire, leaving behind a new vast landscape. An incredible 80% of Venus's surface is made up of cooled lava plains, a silent, vast sea of solidified fire, testifying to this cataclysmic past. And scattered across this ancient lava-sculpted landscape, there are literally hundreds of thousands of volcanoes in one form or another, ranging from small domes to immense shield volcanoes. Additionally, there are approximately 900 impact craters to be found on Venus, although none are less than 3 kilometers in diameter. This curious absence of smaller craters is due to the sheer density of Venus's atmosphere. Anything smaller than about 50 meters in diameter would fragment and burn up completely before it even had a chance to hit the surface, consumed by the crushing fiery embrace of the atmosphere. And finally, let us gently shift our focus to an invisible yet crucial aspect of Venus, its magnetosphere. Venus, to the quiet surprise of early scientists, doesn't possess its own magnetic field. This was a profound and puzzling discovery, as Venus's composition, its internal makeup, is remarkably similar to Earth's, which generates a powerful magnetic field from its molten core. But without more definitive data, it remains hard to say precisely why this might be. A study published in the journal Earth and Planetary Science Letters in 2017 suggested a gentle hypothesis. Perhaps it was to do with the absence of a massive impact in Venus's early history. Earth, as we know, experienced at least one such colossal impact, the very event that is thought to have formed our moon. And it is entirely possible that this titanic collision played a crucial part in kickstarting our planet's magnetic dynamo, that swirling engine of liquid iron that generates our protective field. But Venus, it seems, never experienced such a momentous impact. Perhaps this explains the profound lack of a similar field, a missing shield in its cosmic armor. Regardless of the precise reason, the consequence is clear. As a result of lacking its own inherent magnetic field, solar and cosmic radiation interact much more directly and intensely with the upper atmosphere of the planet. This interaction can sometimes produce fleeting bursts of lightning, silent electric discharges in the thick atmospheric soup, and contributes to what is known as an induced magnetosphere. This is not a planet's own generated field, but rather a temporary weaker magnetic effect created by the interaction of the solar wind with its atmosphere. The solar wind, that relentless cosmic current, also ceaselessly strips off the low-density molecules from Venus's upper atmosphere. Meaning Venus, much like Mercury, possesses a tail similar to a comet's an ethereal wisp, trailing behind it as it journeys through space. In rare particular conditions, this invisible tail can even gently tickle Earth. When our two planets are in conjunction with each other, a subtle unseen connection across the vastness. Unfortunately, however, this planetary tail is not visible with the naked eye, remaining a quiet phenomenon detected only by our most sensitive instruments. Sadly, as we conclude this portion of our quiet contemplation, we have come to the end of our current exploration of Venus. But it is a world that continues to beckon, to pose profound questions, and to inspire new journeys of discovery. If you have found joy in these quiet revelations, there are many other stories of our solar system's planets awaiting your gentle attention. Our cosmic home is filled with truly incredible sights, from fiery worlds to icy moons, and there is always more to discover, more whispers from the cosmos to listen to. For now, thank you for joining me on this quiet journey, and I hope to see you again as we continue our gentle exploration of the boundless wonders of the universe. As we linger on the image of Venus, this planet of stark contrasts, we find ourselves pondering its profound mysteries. The absence of a magnetic field, especially when compared to Earth, is a silent, enduring puzzle. It speaks to fundamental differences in planetary evolution, to paths divergent despite similar origins. Was it the titanic impact that birthed our moon, which also stirred the dynamo in Earth's core, giving us our powerful magnetic shield? And if so, does Venus's serene, undisturbed past, its lack of such a cataclysm, explain its vulnerability to the solar wind? These are not mere scientific questions. They are deep philosophical inquiries into the nature of planetary destiny, into the subtle nuances that can lead two seemingly similar worlds down vastly different paths. The immense pressure of Venus's atmosphere, the relentless greenhouse effect, paint a picture of an alien world almost beyond human comprehension. It's a vivid illustration of a runaway process, a planet caught in a thermal embrace that tightened until it became a suffocating grip. It serves as a quiet, powerful reminder of the delicate balance that exists on our own Earth. How easily that balance can be tipped, and how precious our atmosphere is. The ability of our probes to withstand such conditions, to send back those first grainy images, is a testament to human ingenuity in the face of overwhelming odds. Those pictures born from a struggle against unimaginable forces are not just data. They are victories, quiet declarations of our enduring curiosity, and the tantalizing fleeting whispers of phosphine in its atmosphere, hinting at the possibility of life in the most unexpected of places. A fragile existence, floating in the cooler upper cloud layers, far above the fiery surface, add another layer of intrigue. Imagine tiny resilient microbes finding a way to thrive in an environment hostile to nearly everything else we know. This is a question that truly ignites the imagination. A tiny spark of life in a cosmic furnace, urging us to send new missions to listen more intently, to see if Venus in its veiled heart truly holds this most precious of secrets. The upcoming missions to Venus from various nations, and even private ventures, symbolize a renewed focus on this enigmatic world. After decades of being relatively overlooked, Venus is once again drawing our attention, a testament to its enduring mysteries. Each new probe will be an extension of our collective senses, designed to peer deeper, to listen more acutely, to unravel the remaining secrets of its atmosphere, its geology, and its profound divergence from Earth. We are still learning, still piecing together the grand story of our solar system, and Venus, the veiled temptress, holds many more chapters yet to be written. In the quiet of the night, we can almost feel the gentle weight of Venus's atmosphere, the distant hum of its swirling clouds, and the faint, enduring promise of discovery that it holds. It is a world that reminds us that beauty can be deceptive, that even in the most hostile environments, there are layers of wonder waiting to be uncovered, and that our curiosity, like a gentle, persistent light, will always find a way to pierce the deepest veils. Our quiet journey through the solar system has gracefully brought us to a familiar, yet endlessly fascinating destination: Earth, our home. It has been a constant, comforting presence throughout our cosmic wanderings, a vibrant blue jewel in the vast silence. It possesses a surface ocean of life-giving water, an oxygen-rich atmosphere that sustains countless forms of existence, and a comparatively powerful magnetic field that acts as an invisible shield. But beyond these remarkable features, Earth holds one truly unique characteristic. It is the only place we know of that contains life, a vibrant symphony of existence that continues to humble and amaze us. And yet, even though we live here, even though every breath we take is intertwined with its rhythms, there is still so much we have yet to learn about our own planet. So what truly makes this little blip in the vastness of space so profoundly special? And what have we, through centuries of gentle inquiry and quiet observation, discovered about it so far? Let's start by giving ourselves some context, a gentle reorientation to this familiar sphere. You may have heard people in moments of playful description refer to Earth as pear-shaped or even egg-shaped. I think this is a bit disingenuous, perhaps designed to make us imagine a very odd-looking Earth. While it is true that our planet is not a perfectly smooth sphere, it is a subtle, gentle deviation. Earth is indeed wider at the equator than at the poles, but only by about 45 kilometers. This slight bulge at its waist is a direct result of the planet's own graceful rotation, spinning gently on its axis, causing it to subtly flatten at the poles and swell outwards at its middle. This means the furthest point from the Earth's center of mass is not the majestic top of Mount Everest, but rather the summit of the Chimborazo volcano in Ecuador, closer to the equatorial bulge. On average, the Earth measures approximately 742 kilometers in diameter, a perfectly sized home for the intricate tapestry of life it cradles. Earth has long been the quiet focus of ancient scientists, philosophers, and thinkers as they wrestled with the profound question of our location in the universe we inhabit. Does the universe truly revolve around us, or do we, with humble grace, orbit the radiant sun? And dare I whisper this, in our modern age, was the world flat or round? Though the idea of a round Earth had been gently bandied about by Greek mathematicians since the 6th century BC, it wasn't until Eratosthenes, around 240 BC, that the circumference of Earth was meticulously estimated. The method he employed was quite ingenious, a testament to the power of simple observation and elegant deduction. He heard a whisper that during the summer solstice in Siena, a city in southern Egypt, the sun was directly overhead, casting no shadows at noon. But in Alexandria, a city to the north, the sun still cast a discernible shadow. Using the precise angles of these shadows, this remarkable scholar was able to work out the circumference of the Earth with astounding accuracy to within 5 to 10% of its true value. It was a silent, profound leap in human understanding. The 16th century gently ushered in a profound revolution in our cosmic understanding, the heliocentric model. Through the quiet brilliance of Nicholas Copernicus, the elegant mathematical predictions of Johannes Kepler, and the meticulous observations of Galileo Galilei, we gradually humbly discovered that the sun, not the Earth, is the true center of our solar system. Today, building on the luminous legacy of these and many more brilliant minds, we now know that we are the third planet from the sun and one of the 4 terrestrial rocky planets, a solid foundation in the vastness. Our Earth gracefully orbits, on average, 150 million kilometers from the sun, its cosmic dance partner. It draws closest at its perihelion to 147 million kilometers and swings furthest at its aphelion to 152 million kilometers. It takes 1 year, quite unsurprisingly, to complete a full orbit. But what is truly interesting is that our very method of keeping time is perhaps not as exact as you may first think. For instance, Earth actually takes approximately 365.25 days to complete one orbit around the Sun. This subtle fraction is precisely why every 4 years we introduce a leap year, adding an extra day to account for that quarter of an extra day in our annual journey. And our month, a word closely connected to moon, was meant to match up with an orbit of our moon around the Earth. Yet the moon takes 27.3 days to orbit Earth once, and our calendars in their practical necessity don't perfectly reflect that. After all, it would be quite difficult to fit months of that precise length into a neat 365-day year without some messy leftover days. So, those in charge of making calendars throughout history in their pragmatic wisdom mostly didn't bother trying for perfect lunar alignment. And in a similar fashion to our years, our days aren't exactly 24 hours either. A sidereal day on Earth, or in other words, Earth's rotation of 360 degrees relative to the fixed distant stars in the sky, is roughly 23 hours and 56 minutes. So, where do those missing 4 minutes go every day? Well, the quiet answer lies in how we measure our time. We don't actually use a sidereal day for our everyday clocks. Instead, we use a solar day, which is the time it takes for the sun to go a full circle in our sky and reach the same exact place as it did the previous day. How is this subtly different from a sidereal day? It's because Earth isn't stationary. As it gracefully orbits the sun, it moves slightly forward each day compared to its position the previous day, subtly changing the angles relative to the sun. It needs those extra 4 minutes to have the sun lined up exactly overhead again each day, which is what gives us our familiar, precise 24-hour days. But it gets even more delightfully complicated than that if you truly wish to delve into the subtle intricacies of cosmic time. Due to Earth's slightly elliptical orbit and its graceful axial tilt, true solar days can actually vary by up to 30 seconds throughout the year. To gently counterbalance this subtle variation, we use what is called the mean solar day, which averages all these tiny fluctuations throughout the year. This allows for the consistent, steady rhythm of our clocks. Going even further, the gentle, persistent tidal drag from our moon is actually slowly slowing down Earth's rotation. Our days have in fact become longer by about 2 milliseconds per century. This subtle shift doesn't make a noticeable difference to us in our fleeting human lives. But 500 million years ago, models show that days were under 22 hours, and there were roughly 400 days in a year. Imagine a world with a slightly different rhythm, where time itself had a different beat. With all this subtly combined, keeping time is probably far more complicated, far more wonderfully intricate than you might have initially thought. The graceful rotation of Earth can be beautifully observed from the ground through time lapses at night, where the fixed field of distant stars appears to move in gentle arcs across our view. The exact axis of rotation of the planet can be seen from the points the stars seemingly circle around a silent pivot point in the vast cosmic dance. The Earth's orbit around the Sun, combined with its elegant axial tilt, means that throughout the year, the Sun's position at the same time every day will appear different in our sky. This beautiful phenomenon can be seen vividly in an analemma, a photo created from combined shots taken throughout an entire year. As you can see, the Sun gracefully moves in a figure of 8 shape throughout the course of the year. The gentle north to south movement is due to the axial tilt of the Earth as it orbits something you've no doubt noticed with the changing seasons, with the Sun being higher in the sky during summer than in winter. The subtle variation in its east to west position is due to the orbital eccentricity of Earth, combined with something called the equation of time, which is very basically what we talked about with the tiny variations between a sidereal day, a true solar day, and a mean solar day. This graphical representation, the analemma, beautifully shows the combined effects of these intricate factors: the equation of time, the axial tilt of Earth, and its orbital eccentricity. If you were to take an analemma on another planet, each planet's analemma would look uniquely different, a cosmic signature. Here in simulations, you can see what it would look like on the other planets. Again, the differences are all due to the unique characteristics of each planet's days, their orbits, and their subtle axial tilts, each a unique expression of cosmic motion. Earth's rotational axis is roughly 23.5 degrees to the plane of the solar system. This precise axial tilt, this gentle lean, is precisely what bestows upon Earth such varied seasons. Interestingly, the changes in temperature between seasons are not mainly due to the closer proximity of a point on Earth during that hemisphere's summer. Rather, it is primarily due to the amount of sunlight hitting that point and the angle at which it strikes. Being an extra few thousand kilometers closer to the Sun doesn't play such a large role when the vast distance between the Earth and the Sun is already 150 million kilometers. If it did, we would find that the Earth's perihelion, or the closest Earth gets to the Sun in its orbit, would make a massive, noticeable difference, because at perihelion, we are 5 million kilometers closer to the Sun than at aphelion, the furthest part of Earth's orbit. If you still gently think it does make a significant difference, could you perhaps guess when the Earth last reached perihelion? It was actually only in January, a quiet testament to the subtle power of the Sun's angle. What truly makes a profound difference to the temperature between seasons is the surface area the sunlight hits. During summer, when the Sun is higher overhead, its rays strike the Earth more directly. This means a point on the surface will be exposed to a much more concentrated amount of sunlight, like a focused beam. During winter, with the Sun low in the sky, the same amount of sunlight spreads out over a much larger surface area, its energy diffused like a gentle, wider spray. Also, during summer days are longer, allowing more sunlight to reach the surface compared to winter. As this precious sunlight gently hits the ground or the vast oceans, its energy is absorbed and heat is released into the atmosphere, warming our world. Earth possesses a reasonably dense and compact atmosphere, a protective enveloping blanket of gases. Although it has a low overall mass in comparison to places like Venus with its immense crushing atmosphere, or Titan with its thick hazy veil. Our atmosphere consists mainly of 78% nitrogen, 21% oxygen, and a modest 1% argon, with trace amounts of other crucial gases like carbon dioxide. Water vapor is also a vital variable component in the atmosphere. It can fluctuate wildly from only 0.01% to as much as 4%, but it averages out at about 1%. It is this very water vapor that, in its subtle dance of condensation, forms the clouds we see drifting across our skies. And ozone O3 is also present in a special delicate layer in the atmosphere called the ozone layer. This vital ozone layer absorbs a great deal of the harmful ultraviolet radiation streaming from the Sun, acting as a crucial shield that protects life on land and allows it to flourish. Without it, Earth would be a far more dangerous place to venture outside for life forms, like us, exposed to the Sun's harsher rays. The atmosphere, in its remarkable design, truly serves life in many different intricate ways. It provides useful gases essential for breath and growth, like oxygen for animals and CO2 for plants. It causes small meteors, those fleeting cosmic pebbles, to beautifully burn up before striking the surface, painting silent fiery streaks across the night sky. And it even gently moderates temperatures around the globe, preventing extreme swings. With the atmosphere retaining some of the heat from the Sun, the Earth would otherwise be a far chillier place, averaging about 8 degrees Celsius, compared to its actual comfortable 15 degrees Celsius average. It is a subtle, yet profound, warming embrace. Now the atmosphere also gracefully drives one of the most essential systems to us, the water cycle. Imagine a ceaseless, elegant ballet of water moving between land, sea, and sky. As the Sun gently warms the Earth and its vast oceans, water on the surface evaporates, rising invisibly into the atmosphere. This water vapor later cools and condenses on tiny dust particles in the air, forming the clouds that drift above us. In this ethereal form, the water particles can travel considerable distances, carried by the winds, before eventually falling back to the surface in the form of rain, snow, or hail. This precious water is then transported back to the oceans through rivers, completing the cycle, nourishing all life along its path. Not only does this traveling water subtly erode and shape the surface of our planet over long eons, but it is also profoundly vital to the very life that thrives upon the surface, from the smallest bacteria to the tallest plants to the most complex animals. All need water to live, a fundamental requirement for existence. Another hugely important system on Earth that I've already quietly mentioned is Earth's hydrosphere, predominantly its vast and mysterious oceans. The very prevalence of life on land, the vibrant diversity we see around us, is hugely reliant on the sprawling oceans of Earth, that deep blue embrace. The oceans on Earth are truly vast, making up about 1/400th of Earth's total mass. To give you a gentle sense of the immense scale of Earth's oceans, imagine this: if the Earth's surface was perfectly smooth, completely devoid of mountains and valleys, the entire planet would be covered in a single continuous ocean, almost 3 kilometers deep. Luckily for us, that is not the case, and the Earth's surface is wonderfully variable, a tapestry of peaks and troughs, land and sea. This remarkable variability is due in part to quite a unique feature of Earth, its plate tectonics. You see, Earth has a comparatively thin crust, like a delicate skin, underneath which lies a hot and actively churning mantle, a semi-molten layer. We sometimes feel the powerful, yet subtle effects of this mantle flowing beneath us, as the colossal plates on the crust gently bump, scrape, and pull apart from one another. This ceaseless motion, this slow, powerful breathing of the planet, forms the majestic volcanoes that erupt with fiery displays, the sudden tremors of earthquakes, the towering mountains that reach for the sky, and the deep, mysterious trenches that plunge into the ocean depths. Using an exaggerated 3D map of the elevation of Earth, you can clearly see these magnificent mountain ranges and profound deep trenches that have formed thanks to the tireless dance of plate tectonics. As a result of this, you might gently think that plate tectonics are dangerous to life on Earth, and perhaps to individuals caught in the wrong place at the wrong time, they certainly can be. But this continuous renewal of the surface, this ceaseless geological activity, keeps the Earth fertile and fresh, constantly replenishing its resources and shaping new landscapes for life to embrace. Beneath the mantle, at the very heart of our planet, lies the Earth's core, consisting primarily of iron and nickel. Earth holds the distinction of being the densest planet in the solar system at 5.5 grams per cubic centimeter, and this profound density is mainly due to its colossal core. It is very big compared to the cores of other planets, with the outer core reaching roughly 5,000 kilometers in diameter. The inner core is thought to be solid, yet it exists under extreme pressures of 360 gigapascals and reaches a searing 6,000 degrees Celsius in temperature, a silent, fiery heart beating at the very center of our world. The core is also where the magnificent magnetic field of Earth originates. As the molten outer core gracefully moves and churns, it converts kinetic energy into electrical energy, generating a massive magnetic field around the planet. Imagine it like the invisible magnetic field surrounding a giant dipole magnet, wrapping our entire world in a protective, unseen embrace. This magnetic field also profoundly serves life on the ground, acting as a crucial shield. It gently diverts solar winds, those highly energized particles streaming from the sun around the planet, and guides them towards its poles. Without this invisible guardian, solar storms would regularly bathe the Earth in deadly charged particles, which would slowly destroy our DNA and strip away our precious atmosphere. But with it, we are lucky enough to witness the breathtakingly beautiful aurora, where these particles gently interact with the upper atmosphere, painting the polar skies with shimmering curtains of light. The most common color for auroras on Earth is a luminous green, due to the solar wind's gentle interaction with atomic oxygen, a silent, ethereal dance of light and energy. There's one more very unique aspect about Earth that I want to gently cover in this chapter, and that is its moon, known to us simply as Luna. Although many other planets in our solar system possess moons, Earth has the largest moon relative to the size of the planet. The beautiful result of this is a spectacular sight in our night sky on a clear evening, a huge celestial object so intimately close that we can discern details on its surface with our naked eye, a constant companion on our journey. But having something so massive so close to us has a very real tangible effect on our planet too. The moon subtly influences our ocean tides through its own gravitational pull, which gently tugs at the water in our vast oceans, causing a rhythmic bulge as the planet rotates. This gravitational bulge even exists in the Earth's crust, though to a less noticeable degree. However, these constant tidal forces, this subtle, rhythmic pulling, could very well be the profound reason why Earth has such active plate tectonics, keeping our planet dynamic and renewed. Having gently explored all these intricate factors, it truly blows my mind to quietly think how many precise conditions, how many delicate balances had to be just right for life to have formed and developed on Earth. It is a testament to an almost unimaginable cosmic synchronicity. But as a beautiful result of all these factors aligning, we are now a part of a species with a population of more than 8 billion people, a species with the very intelligence to question our own existence, to wonder at our place in this boundless universe of ours. It also profoundly amazes me to simply gaze upon the sheer beauty of this planet. Thanks to the quiet endeavors of space exploration, we are now granted a view of our home that people would have only dreamed of a mere century ago. Will anything else in the vastness of space ever be as beautiful and welcoming as this our home planet? Let us ponder this question in the quiet of our minds as we allow the image of Earth, vibrant and teeming with life, to gently settle. For now, thank you for joining me on this particular journey of wonder. This has been our last gentle contemplation on our solar system's inner planets in this series, and it has been quite a journey, hasn't it? I really hope you've enjoyed this series and saw something that helped you experience the same profound feeling of awe that I get when I look out across the intricate tapestry of our solar system. But don't worry, even though this series is done, there's plenty more to learn about. The universe is an infinitely vast place, and there's always more to discover, more quiet whispers to listen to. Perhaps one day we will even find a place that's as fascinating and incredible as the planet that we started out on.